particularly talking about today's, the context of systems cluster. I'm going to present how our cluster is supporting the aircraft programs and the research, applied and fundamental research, and towards meeting the vision objectives of CSIR-NL, CSIR itself, and of course the as a whole the country. So for all these aircraft programs, we have combinedly all the 5 systems cluster divisions. We are supporting the activities for, as you see here, the avionics systems, electrical system, flight test instrumentation as part of the aircraft requirements, and flight mechanics and controls, acoustics testing is part of it, UAV solutions, then model-based systems and software engineering, electromagnetics, and of course other activities towards embedded systems as part of it. And also, as to reiterate again, like yesterday's, the systems cluster hosts a lot of national facilities per se to support primarily the aircraft programs and also towards the research activities in the domain, which includes many of them, as we talked here, apart from the MAV tunnel, acoustic test facility, and anechoic chamber, aircraft simulator, and so on, which the details will be there further, and we can go through that. Coming back to systems cluster, these are the 6 divisions per se: aerospace electronics, flight mechanics and controls, computational electromagnetics, unmanned aerial vehicle systems, systems engineering, and acoustic test facility. I'd like to take through one by one. So as per the aerospace electronics systems division activities, we support primarily the 3 major subsystems of aircraft: avionics, electrical, and flight test instrumentation. Apart from that, we also have the design development of systems, technologies, and products for aircraft applications, quite critically. I'll be just going through very quick, but the details are there, we can go through later. These are some of the indigenous, unique products in the country. Particularly, I'd like to emphasize on the IFCC, which one more slide is there, which is one of the unique computer in the country with major capabilities. We also have the state-of-the-art process and procedures towards aerospace practices in terms of systems, software, and of course the qualification and certification, which is one of the very, very critical as far as the industry is concerned, which we have established the complete process in the last 3 decades. Also, we have, as a system, support a lot of test facilities, test rigs towards system design, verification, validation of all the subsystems that we talked about, apart from, of course, basic activities towards it. Okay. And also about the activities that we are planning towards some of the unique requirements in the future, talking about the systems, particularly talk about advanced technologies for system certification. Today's context of system certification is at LRU level, but we are targeting towards the system level, which is unique in its own approach. One more important is, of course, is the concept of model-based systems engineering, model-based software engineering, which already we have in practice, and that's something that we have to focus on. This is one of the unique computers that I would like to state here, that which has all the state-of-the-art technologies in the country, and probably it is comparable to elsewhere in the world also, which is completely designed, developed, and partially certified in the country with every resources except the component that we buy from outside. The rest of the design is from in-house, which of course is multidisciplinary, which involves all the systems cluster divisions, including the outside agencies as well. And in brief, that we have aerospace, electronics and systems. We do have some products in avionics, electrical, test rigs and so on, which is summarized, and I request all industry friends to get into our website. We have more details. Now we talk about flight mechanics and controls. Anyway, I'm not the expert in this, but I just present a brief on that. Flight mechanics and controls have different vertical, talking about control and handling qualities, which caters to all the national programs of the country. And that's something that unique of itself. And flight mechanics and controls host the national team for control laws, which is a unique combination of multiple agencies across the country. Apart from that, of course, this is what we talked about. We have the way of parameter identification is one of the unique capabilities of the division. Again, if you look at the whole spectrum of all the aircraft programs in the country is being addressed with this group of scientists. Also, the division has excellent capabilities in the aircraft simulators, right from design simulators to pilot evaluation and so on. So, with, of course, our own aircraft plus majorly supporting the military aircrafts of LCA, Tejas, and so on. And definitely, the flight mechanics and controls is known for its control algorithms. For you name a program in the country, definitely NIL has a presence there, and it has made national impact on the complete controller capabilities for various programs. And again, I said the details will be there in the internet, we can look at it. The other vertical is on the computational electromagnetics, a unique laboratory in the country, and probably I would say the one of the first in the country to look at the major technologies for stealth, which is of course today's importance. And apart from that, it does have a lot of test facilities, and I'd say these test facilities are being used not only by Indian industry but also the international major OEMs like Boeing are using these facilities for unique capability, and it has a vast range of facilities for completely in the RF domain for various applications, which is certainly not there elsewhere in the country. And these are few of the test facilities that our CEM division has. And again, the details will be there in the internet. Coming back to the UAV subsystems, apart from the traditional what we call MAV or UAV technologies, products and process, the division also hosts a lot of test facilities. One of the key facilities, of course, the Aerodynamic Research Tunnel, MART we call, which has a lot of capabilities for MAV applications in the domain. And also it has other test facilities for dynamic testing of systems, and with all the sensors embedded part of it for actual measurements and evaluations. As it's known that NL has a vast scope and the different varieties of MAVs designed, developed, and of course commercialized very successfully in the country, with many private industries already taking part in this. And we have a variety of fixed wing, rotary wing, hexacopter, octocopters, and so on. Certainly, I think we have a good presence across the country. This is one of that, which has an octocopter having payload capability of 20 kg and so. And this is today's in the UAV terminology. I think there is a buzzword of eVTOL, and which is what the requirement of today to look at the capabilities and the demand for various applications, not necessarily civil, but of course strategic applications also. NL has made significant progress in this, and the product will be soon cleared for operations in the coming days. Coming back to systems engineering, it's a new division formed last 2 years back, and it primarily addresses the systems engineering aspects of the program, talking from both as a system level and further going down to software and others. And as of now, it's primarily talking about all the ARP standards, which in aerospace practices 4754 is the main reference for which any system design of an aircraft, and even including the aircraft design, should start with the systems engineering process, which has all so and so, which is the requirement for today's aerospace practices as a mandatory requirement. Apart from that, the systems engineering vertical also addresses the typical aircraft activities like mass and CG, calculations, analysis, and so on, so, which is one of the critical domain for aircraft requirement. And going to the acoustics, acoustic test facility was first, of course, commissioned back in 1986. As recently as last decade back, it was only one facility. All the satellite which is launched from India have gone through this facility right from 1986 till recent last 5-6 years, where one more facility was set up in the ISAT of ISRO. And we have to be proud as a member of this facility, because we again redesigned one more facility for ISAT with NL's expertise. This is one of the unique requirements, and even today this facility is being functional with various systems, satellites, rocket subsystems, and so on. And ATF also has the capability for noise and vibration measurements, and with specialized outdoor experimentation as per approvals required for environmental studies. With that brief, I'd like to go one step further and talk about, as a whole, systems cluster. What is that? We are giving a one-stop solution. For systems per se, when we call systems aerospace systems, we have aircraft programs on one side, certainly yes, and we have systems, technologies, products and facilities, and we have our own test rigs to provide our design capability. And if you look at, these are the technology or technical verticals that each of the division or a combination provide, right from modeling simulation, PID, controls, electromagnetics, antennas, model-based systems engineering, and so on, so with the complete spectrum, which is required for any system on an aircraft, which is what the unique capability of this cluster, and providing complete solution to ensure that the product can go to aircraft as required. These activities are framed or embedded into the systems cluster with an objective of meeting the vision of CSIR NL with all the technology, aircraft programs, technologies, and R&D capabilities that we have to address NL's mission itself, CSIR's vision, and of course towards the nation's vision of indigenization or Atmanirbhar Bharat. So with all these things, what are we achieving? That one-stop solution to expand one more step further is to have something called concept to certification. So any program that we take, it does start with the concept, and ultimately the concept has to go to aircraft. So which means it should include the complete system, hardware, software, certification, qualification. So the unique capability is to have this system certified and put into aircraft. So the systems cluster has the complete know-how or the component which are required to take our concept to certification in various phases. So this activity is completely on the simulation platform, modeling and simulation activity. Then we go to the next, the model to the hardware. We integrate the concerned connected hardware to that, and then the hardware to complete certification. This process is supported by various test platforms. We have test rigs, test platforms, and ultimately it has to go to the ground facilities, or ground test facilities. We call every system to have this. Before we take the product or technology to aircraft, ground testing is the must, which is mandatory as part of the process. And then we go to aircraft flight test, and then we have the complete certification of the systems, which is embedded part of it. So with this, I think the total systems get integrated, and I would say that the systems cluster has the complete solution to do that. With this, I'd like to close, and I thank all the chairman, cluster chairman, and heads of the systems engineering divisions, systems cluster, And of course, the preparation of all the slides is from various divisions. Thank you very much. If there are any questions, I'd like to answer.
Thank you for enlightening talk. We invite Harish Barsilia sir to deliver the next talk on the materials cluster.
ಮೇಲ್ಗಡೆ ಟಾಪಲ್ಲಿದೆ ಬಂದೆ ಆಫ್ ಮಾಡೋದು ಮಾಡಿದೆ
Good morning to all of you. My name is Harish Barsilia. I'll be presenting the competence, various facilities, and some of the technologies which are available to the industry friends from the materials cluster. So in this cluster there are three divisions: surface engineering division, then we have material science division, wherein we work in the area of various new materials which cater to the needs of the aircraft industry. And then we have Center for Carbon Fibers and PPEX. As name suggests, we work in the strategically important materials such as carbon fibers and PPEX. In the coating division, we develop large number of functional coatings, and also we have a vertical on developing various sensors. My two other HODs, I think Dr. Sujata and Mr. Tarun, they are available for any technical queries related to materials and carbon fibers. So as you know that aircraft requires large number of materials and the coatings. So as you will come to know it a little later, CSRNL has the core competence in developing the CFRP and GFRP kind of composite materials for airframe structures. We also have competence on developing radome kind of materials, extremely high temperature materials for engine, and also kind of thermal protective coatings and high temperature coatings. In addition to that, as yesterday it was pointed out by Jadhav sir, a large number of requirement for these advanced coatings for stealth applications, such as EM transparent coatings, EMI shielding coatings, anti-icing coatings, radar observer coatings, fire retardant coatings, of course, for the engine applications, and of course, a lot of other competence in the area of PU-based coatings and thermal barrier coatings. So in my next 10 minutes, I'll try to take you through some of these technologies which are available for commercialization to the industry. So coming to the eco-friendly coatings for the corrosion and the wear protection. Corrosion is a very serious issue because on an average, the life of a typical aircraft varies from about 25 to 30 years. So we need to have the solutions which address the corrosion aspect of these materials such as aluminum and steel. So especially if you see in the conventional aircraft, still 50% of the aluminum is used, and to enhance its corrosion, we provide the corrosion protection layer by using conventional methods which are now being slowly banned all over the world. So toward that, CSRML has developed an eco-friendly coating process which doesn't use any of these hazardous chemical, and it has been certified by CEMILEC, and it is ready for use in our own aircraft program as well as for other applications. This also can be used for the general engineering applications. Another important eco-friendly technique is coating is the cadmium coating. Cadmium, as you know, it has low coefficient of friction, and it has excellent corrosion resistance, especially on the steel material. So we have come up with an eco-friendly coating process, which we call it zinc nickel electroplating process, which is being certified for the component level. Another important coating, which is of course has been developed for the vehicle engine applications, but it can be customized for other engineering applications such as automobiles, wherein we use nickel silicon carbide wear resistant coating, and this coating has also been certified, and it has been used. It was used for the Nissan class of UAV. Of course, our expertise in the area of various electronics coating, we cater to the needs of all the INSAT class of satellites. In these satellites, the coating developed by ANEL goes to the space for which exhibits very high reflectivity and very low surface roughness. Of course, in our search to go for the eco-friendly coating processes, we are now in certification stage of development of another coating wherein the primer layer itself is being substituted by another eco-friendly layer, and this process is now under certification. We have a large number of other coating technologies. Because of the lack of time, I will not be able to cover all of these. So most important are like PVD hard and super hard coatings, protective coatings for magnesium alloys, thermal spray based coatings, self-heating coatings, so on and so forth. Coming to the magnetic sensor, the sensor is a very, very important element, not only in the aircraft industry, but also in the general engineering applications. Conventionally, the Hall sensor is used for automobile as well as in the aircraft industry, but it has its own limitations. So we have come up with a fab facility wherein we can develop these giant magnetoresistant sensors, and this sensor can be customized as current sensor for monitoring the health of your battery, or also in the aircraft monitoring the current in the aircraft structures, pressure sensors, speed sensor, displacement sensor, and proximity sensor. We are already interacting with large number of industries, and one or two technology transfer have already taken place. More importantly, we are trying to use this magnetic sensor as a current sensor, mostly for electric vehicle applications. We are in discussion with SKF Bearing Limited in Bangalore. Sorry. to use these sensors as ABS applications. As you can see in this graph, that the market share of the magnetic sensor is to the tune of about $7 billion by 2030. And our aim has been to develop a sensor. Of course, we have already developed a sensor wherein the cost is to the tune of about 150 rupees per sensor. And in the country, if you see, only for the automobile applications, the requirement is about 15 million units per year. So this is the fab facility wherein we can coat on 4-inch silicon wafer, and in one wafer we get about 2,500 sensors, and the yield of this process is about 90%. And we have the associated technologies such as the signal conditioning, and this is a typical sensor which is customized as a speed sensor for automobile applications. Now coming to other kind of sensors and actuators, we have the expertise in developing various accelerometers based upon both the PGFT as well as PVDF materials. Here you can just see that a typical PGFT accelerometer has a range to about 50 G, and the sensitivity is very, very high, 4 millivolt per gram. And these find applications in vibrations, acceleration, short monitoring, and stability control. And they find applications in aerospace industry, defense industry, automotive, and electronics. Now, another important technology in the area of energy sector is the solid oxide fuel cell. We have transferred this technology to 3 companies in the country: BV Ceramics, Chennai, Hydrogen Power 1 from Bangalore, as well as QE in Hosur. So we have 2 kind of technologies here. For example, here in this particular thing, you can just see that this particular cell gives about 14 watt per cell in hydrogen environment. This is the kind of output we are talking about. And in the case of hydrocarbon, that is the methane, the output of this cell is about 0.9 or 900 milliwatt per centimeter square. And we have expertise to tape cast these ceramic materials for other applications as well. Now moving on to the energy sector, as you know that you might be aware that in Bangalore, especially we use this Knalson technology for domestic corporate applications, and this technology is the flagship technology of CSIR-NAL, which was developed in 1990. But because of environmental regulations, this technology is being phased out. So we have now come out with an eco-friendly, a very simple fossil coating process which can be just sprayed on these substrates. And the most important is that it is a graphene-based formulation, and it gives the properties at par that of the internationally available coating technologies. It has been certified as per the International Energy Agency standards, and the transfer of technology has happened recently to Messrs. Supreme Solar in Bangalore. Now coming to the CMCs, as you are aware that yesterday it was told by Dr. Uday Kumar, I am just repeating it. We have the unique facility in the country, that is the chemical vapor infiltration reactor. And this reactor was purchased procured in around 2005. And we developed a large number of composites based upon silicon carbide in the form of the composites or in the form of coatings. And we cater to the needs of the strategic sectors such as DRDO, ISRO, atomic energy, and our own requirement, as I will show in my next slide. And we also work in the area of other kind of ultra-high temperature ceramics, which are required mainly for the missile and other kind of strategic applications. Coming to the carbon fiber silicon carbide CMCs, which is a very, very important technology. You will find that CSIR-NAL has the core competence in both the carbon fiber as well as the silicon carbide. coating technology. So with this, we have developed these deck discs, especially for very high-end cars as well as for the aircraft deck application. These materials are used. The most important aspect of this aspect is that it has very low friction. It has very high frictional performance, and its weight is very, very low, and the life is also very, very high. So this disc is now undergoing certification in RCA at DRDO, and we hope that this will be inducted very soon in our own aircraft, maybe in a couple of years. This is another technology wherein we have done a large number of niche technologies that is in the area of shape memory alloys. So these alloys can be used in the aerospace sector, defense sector, power sector, and automobile. So we have targeted two applications. One is the engineering applications or aerospace application wherein we use them as the actuators and also as the medical devices. In the medical devices, you find that for stent alone itself in the country, the requirement is about say 2,500 crore per annum. And the cost of the device which has been developed by CSIR is about 40% to that of the international market price. Now another important activity which is being pursued since 1960 is the area of failure analysis and accident investigation. This activity was initiated in 1960, and we catered the needs of Indian Armed Forces such as Indian Air Force, Indian Navy, and the Coast Guard. Till today we have done about close to 1,800 investigations, and we also provide the root cause analysis of accidents for the armed forces, which is not available elsewhere. This is unique competence in the country. Now we are trying to broaden the horizon of this competence even for the civilian aircraft as well. Moving on to the carbon fiber technology, which is a very, very important technology for the strategic applications. So it can be used, as Mr. Tarun pointed out yesterday, it can be used in the transport sector, offshore engineering, general engineering, sports sector, energy sector, and so on and so forth. Our focus has been to develop these technology for the aerospace sector. So for that, we have the pilot plant for both the carbon fiber as well as for pre-packed facilities. So this is the polymerization plant, this is the wet spinning, and the precursor fiber. So we have transferred technology for standard modulus grade carbon fiber, which is equivalent to T300 with the tensile strength of about 3.5 and the tensile modulus of about 240 gigapascal. This is will be produced for strategic applications. We are also in the development of intermediate modulus grade carbon fiber, which is equivalent to that of T800, and this will be done very soon. Very interestingly, that we have in another few months' time, we'll have our own pre-pack facility wherein we can develop these pre-packs to the width of about 300 millimeter. So this is the another latest project which we got from the Ministry of Textile to set up a state-of-the-art heat treatment facility for this carbon fiber line, and we are hopeful that this will be commissioned by 2027 and will be able to achieve the desired properties for our carbon fiber technology. Now moving on to various facilities, the cluster is equipped with state-of-the-art facilities, some of which are listed over here, such as electron microscope, nano stress tester, nano indentation hardness tester, microdome spectroscopy, reflectometer, vibrating sample magnetometer, erosion tester, X-ray photoelectron spectroscopy, and so on and so forth. Similarly, we have state-of-the-art advanced materials fabrication facilities, namely lithography and plasma nitriding, high velocity oxygen fuel facility for developing coatings which are a replacement for the conventional chrome plating, plasma spray facility, electroplating facilities, and cold spray. You can visit our website under the technology and facilities to get more idea about what kind of expertise we have and what kind of facilities we have in this particular cluster. Thank you very much for your kind attention. Questions? Any questions?
Questions, I think we will thank sir for a very nice talk on the materials cluster. Next, we will request Venkat Krishnan sir to please enlighten us on the aerothermal science cluster.
Good morning, everyone. This is the aerothermal cluster, and as you can see, it consists of four major divisions. One is the computational and theoretical fluid dynamics division, which essentially does CFD and, where applicable, analytical fluid mechanics. So the second is the aerodynamics experimentations, which looks at flow physics. The third is the testing facilities for wind tunnel testing, and the fourth is the propulsion activities for the entire aerospace sector. So in the under the computational fluid dynamics, the major thrust is on simulation, CFD, of course, and optimization of aircraft NMGs. So this has considerable established and demonstrated experience in CFD simulations for a variety of fluid problems, ranging from almost Mach 0 to Mach 4. So we have a long history and experience of developing in-house codes as well as using industry standard solvers. And in-house tailored codes are customized to handle certain problems in which the industry codes do not work. You see here some of these examples as applied to the new Saras aircraft or propeller blade vortices. We have full stack for the entire CFD, pre-processing, CFD solvers, post-processing, and visualization, and coupled with the in-house HPC at CSIR 4 this offers a one-stop solution to all the computational needs. And turnkey solutions are also offered in terms of data generation, store separation, as we will see, shape optimization, and MDO. Data generation has also been shown by RAD simulation for aerodynamic coefficients, derivatives, control power issues, then air loads for a variety of aerodynamic surfaces, internal and external flows. A whole variety library of codes are available, including open source, which have been customized for these applications, as well as commercial CFD tools. So you can see some of the applications, so you can see the range over which it operates, right from the ANSA to the new version of the Saras to the high altitude platform, Reynolds number simulations through here. And Store separation is a big part of military fighter aircraft problems, and for this, in-house developed machinery solver has been obtained. This has been very successfully implemented in several major programs, including store separation on Sukhoi and the Mirage aircraft. So this has been parallelized for fast computation, and you have ability to look at a variety of stores with the point cloud. So shape optimization is achieved through use of industry standard Numika as well as open source SU codes, and this can lead from optimization of control surfaces, lift enhancement surfaces, or for nacelles, both internal and external fluids. And there's also ongoing effort on multidisciplinary optimization, which has been proven, and it has couplers of the HEADS and Open MDAO software suites. Under experimental aerodynamics, this is for looking at flow physics of a variety of problems, again ranging from low speed all the way to high speed. In this, in the 1 foot tunnel facility, a variety of problems have been looked at, including intake studies, delta wing studies, airfoil studies. Cavity flow control is a major effort for, again, the store separation, which I talked about, but this time carried within internal weapon base. And this offers abilities to carry out pressure-sensitive paint studies, which you'll see in a minute. Schlieren, both qualitative, quantitative, and particle image velocimetry. The base flow facility looks at the afterbody of the aircraft. Essentially, it is like a flow past the rear end of an aircraft or missile or launch vehicle. This is the earlier version of the Saras pusher in the base flow facility. The outer flow can go up to Mach 3.5. The inner can also be replaced by a jet for missile configuration with a pressure ratio of up to 120. So it can look at any kind of nozzle configurations, multiple nozzle configurations, interaction between the flows and the free stream, and of course looking at different kind of nozzle performances. This is a well kind of nozzle for lift vehicles. Again, here too we can do particle image velocimetries or quantitative and qualitative steering. Under the low speed regime, we have a fairly large tunnel, 1.5 by 1.5 meters. And this has the USP of this tunnel is it's a low noise tunnel. Essentially, the turbulence is 10% at max speed, which is like 50 meters per second. And then we can do everything from simple wing test. This is wing under flex in the tunnel to full aircraft forces and moments. Automobiles, which we have done for the automobile industry, landing gears of aircraft or similar, which is done for Boeing. On this, you can see the kind of complicated measurements we can take. Mapped down to the CFD grid is surface flow visualization, steady pressures, unsteady pressures, particle image velocimetry. These are all actual data. This is not simulation. Again, we can also do propeller weight measurements, and this is measurements behind a propeller in the very same tunnel. So we can also do drop test measurements as for store separation and the like, and this shows store separating from a Sukhoi aircraft. We also have a jet aeroacoustics facility because jet noise and prop noise are major issues for today's aircraft and spacecraft. So this has a jet exhausting into an anechoic chamber. This just shows the linearity of the chamber. It's a fairly large one, and we have used it to test several configurations from co-flowing jets for turbofan aircraft to lift-off problems for ISRO. And this is also available for any kind of such test. The steering which we can do can be both qualitative. This shows a lift-off nozzle impinging on the ramp. This is a qualitative picture. We can get a quantitative. This is again actual measured density values. So we can also get on body pressures on any kind of aircraft in the tunnel. This is on the LCA, so this is steady pressures mapped onto the surface grid. Again, this is data available at every grid point in the tunnel or the LCA. We can do this in the unsteady mode also. So by putting this in on any kind of moving jets, like it is shown here, or we can do it on delta wings, where you can see the actual pressure variation on the delta wing itself in an online mode. And this is the time resolved pressure on the delta wing. Totally non-intrusive, you only need to spray the model. And this shows that it matches very well with intrusive pressure sensors. So the National Trisonic Aerodynamic Facilities has been around since 1967 and is the oldest and first supersonic tunnel in Asia even. So it has carried out over 58,000 blowdowns, and over the last 57 years, it's 1.2 meter by 1.2 meter trisonic, goes from Mach 0.2 to 4, and you can do a variety of tests, including Mach number sweep, pressure and roll speed. All the measurement techniques which I mentioned earlier are also implemented on this tunnel. Similarly is the 0.6 meter trisonic wind tunnel facility, also in the EAF, and this again can go from 0.2 to 4 and do the same thing. The additional advantage is you can change the Mach number during the run, which is a very good facility for in-flight testing. The same unit also has the capability of doing model design and fabrication. It shows a number of models which are designed for customer specific needs, including the balances and integration which are carried out. This shows a typical aircraft, combat aircraft model. We can also do balance calibration either for industry or for the balances that we design and generate load matrices. There is capability to carry out a variety of steady and unsteady pressure measurements on the model, and this shows the kind of density which we can put into a model for carrying out pressure measurements. And this shows the again for store separation or drops from aircraft, that we can do it even all the way up to Mach 2. So air intake studies are also carried out for a variety of aircraft. This shows that you can do air intake studies or you can do oscillation studies. Flow visualization using Schlieren, of course, is like I said already a standard technique, which this shows on the reusable launch vehicle. Under propulsion, we have a huge number of facilities which cover pretty much every aspect of the gas turbine engines or rocket engines. So these show some of the major test facilities. This division has also made a number of industry level gas turbines. This is the small gas turbine which provides a thrust of 100 kg. This is what has been actually realized, and they have a test facility where they have already shown the performance of this gas turbine, which is up to industry standards. A micro gas turbine is also being made for just a 5 kg of thrust. Both of these have applications in different domains as the industry will pursue, and this shows several gas turbines which have been made out here. The Wankel engine has been a major workhorse of both the Nissan UAV and several other UAVs, both current and in the future, and this shows the whole offering of different horsepowers of Wankel engines, including that which is repurposed to make electric generator or even twin rotor engines and high capacity engines for even hang gliding. These are all, some of them are transferred to industry, some of them are available for transfer or customized design. So this shows a whole detail of specifications. These are all available on the IDM website. So this also shows the capability for developing specialized bearings and this shows a foil bearing developed in NAL, which has been used by an industry for a compressor, which has been used in a whole other set of client industries. And a cabin air pressure compressor is also being developed using again in collaboration with industry, using some of the technologies developed at NAL, and this shows the performance compared to the standard chart. So this can also be used as a blower. A variant of this can be used as a blower for ventilators. So this shows the indigenous blowers which are developed and transferred to industry. These are, I believe, non-exclusive IPs. So, like I already showed in the first slide, we have a whole bunch of facilities. In great detail, all of the specification and capabilities are listed on the website. You can go through them, and this range from centrifugal compressors to combustors to bearings and ceramic application lab. So this shows some of the test facilities that we have here, and like I said, you can get details from there. Thank you.
Thank you, sir, for a nice talk on the Aerothermal Science Cluster. We request Raja sir to please enlighten us on structures cluster.
Morning to all. Myself, Dr. S. Raja, the chairman of Structural Technology, and I'll be presenting about our capabilities in 3 divisions. So this cluster has major facilities in the structures. We have Advanced Composite Division headed by Dr. Ramesh Kumar. He is the point of contact. And Structural Integrity Division, where Dr. C.M. Manjunath is heading. He is the point of contact. Structural Technological Division is headed by me. So we have various customers, starting from MSMEs to space, ISRO, DRDO and HAL. So our actually business models, we follow R&D, lot of R&D projects we take and conduct research in a wide range of fields in the structural domain, developing future technologies. And our focus is certifiable airframe related technologies. But I am not presenting here the R&D part. I am going to present the matured industrial technologies what we have developed for the past 40 plus years. And with these customers we have been working. Starting with composites manufacturing, we started in the early 90s, but later we have become mature, and you could see we have come to the level of even making partners who would make the airframe components of airworthy in nature, certifiable by CEMILAC, the military certification agency, as well as the civil certification agency, DGCA. So what you see is like a fin component of the LCA, radar, and various other complex geometries. So you can see the top skin of the central fuselage, then various other components. They are very complex in nature. In fact, in early 90s, we started understanding composite tools, very important to manufacture these lightweight materials into a shape that would take actually multi-directional loadings and as well as get into the airworthy standard. So that is how the composite division itself has evolved. They were a group in structural technological division, but today, if you take in India, HAL has that facility and DRDL, and we are definitely proud to say that NIL also has similar facility, that can be useful to make airworthy composite lightweight components. So this is actually a kind of witness to the audience. If you look at the LCA, our composite division has contributed in various parts of the airframe, and the LCA airframe of various versions. If you see, there are many versions now flying, and they have already 2 squadrons. You would see our components are flying in those versions of light combat aircraft. So facilities coming to composite manufacturing. So we have a state-of-the-art clean room, and we have water jet cutters, 2 test facilities, and a biggest autoclave. And needless to say, we have both the autoclave-based manufacturing as well as the low-cost out-of-autoclave also available. So we can think of the very low-cost components for UAVs and other flight structures, as well as the high-end components where you need really high stiffness and strength. You can go for autoclave-based manufacturing. So we also have the capabilities to design and develop composite tools of any complex geometry. You can see this is a very complex LC pylon tool. So such a level, our engineers and scientists have gained experience in this state-of-the-art area. So we have been supporting all space programs in a very critical area called aeroelasticity. So it is basically both aerodynamics and structural dynamics when they interact. The flight vehicle structural stability and response will be a problem. So what we do is we make a calibrated aeromechanically suitable model, which we call it actually aeroelasticity model. So you can see from SLV3, today we are working on the Gaganyaan program. In fact, the test vehicle of Gaganyaan, recently we have qualified for both response problem, which is buffet, and the stability problem, flooded. The challenge was for the ISRO, the gridded fin structure. In any abort mission, the crew escape system has to come back. But this gridded fin, we cannot solve it because it has a multi-directional planes. So we could not do it. The only way is post-simulation using CFD and CSD, but we did not apply that. Immediately we went with the model testing and qualified, and we could see they could successfully conduct the abort mission test using that test vehicle. So such capabilities are available with us. So coming to the service to the Indian Air Force, so we developed a technology certifiable by CEMILAC in 2012. We applied for Mirage integration and as well as Sukhoi and other aircraft. This is basically carriage handling. When you integrate any weapon stores onto the fighter aircraft, obviously carriage handling envelope has to be qualified with those stores. So we actually developed with our understanding for a bottomed aircraft how we can generate structural data in integrating the weapons through experimental and mathematical approach, a hybrid, and a range of weapons we integrated and then certified the carriage handling envelopes for IAF. They are all flying now in the Sukhoi and other platforms. We have impact and crash facilities, both for low velocity and high velocity. We also have drop test facility, sled facility is there, And our customers are like police, aerospace, and other MSMEs, and government sectors like R&D Pune, ADA. So all the impact and crash related both simulation as well as test facilities we have. I think industry can definitely use all these facilities. When we started our 2-seater aircraft and 14-seater and now 19-seater, so we felt there is a need to have a design for airframe, like design centers. So you can see the various capabilities. So we have a team that works on structural loads. Today we are the consultant for even ADE on this structural loads. So our team has the capability to generate the structural loads as per FAST standards as well as BEL standards. And airframe design, certification, both FAR and JAR VLA. And we have the basic stress and buckling clearance, aeroelastic clearance, as well as we have the radome design capabilities. Okay. Actually, these capabilities are not only for the developmental aircraft, what we are doing, also for military certification. As you know, continuously, operational vehicles will go for upgradation. So, recently we have certified many systems on V17, both the versions. So, these capabilities are very useful when you integrate new system, how to certify them. Okay, it is also again carriage handling. So this is we have done, and also recently MSME has used our facility. So what you see here is the satellite. So the Pixel Space, they have come to us and asked us whether we can qualify their satellite, under vibration, environment. So we have done now 3-4 satellite qualifications. So MSMEs can definitely use this facility. And also some the private companies have used our vibroacoustic capabilities. Like you develop a UAV or any MAV vehicles, then they have to be qualified for the noise environment. So we have helped them. 2 companies taken our service. So we have a set of capabilities that can be used by MSME. Both simulation also we have, as well as the testing facilities. When your vehicle is in flight, we can measure and tell you the noise mapping of that operation. Coming to the structural integrity, this actually division has various capabilities. You can see how we served our nation. So this is a MiG-21. So long time back our seniors have done the total technical life extension for that aircraft. And I think 3-4 years back, we have done the landing gear, fatigue life extension. Here, our team has developed the technology which involves SN curve generation after identification the material. Okay, we have to do it at the lab level, instrument the landing gear, do the in-flight measurement, and then apply the fatigue computational approach to see whether the landing gear can be allowed to be with the aircraft landing for the life. So 300 landings extension can be possible. The team found and it is already happening. So same way they have also been working with the Indian Air Force for the technical life extension for helicopters. So such capabilities are there, and here it is work together, grow together model. MSMEs can take even projects from open tender and they can take our service. So we have the technology, we will work with you, and then we can complete that task. So we have done that with MSMEs in weapon integration. Here too, I think is possible. And another major capability what we have is full-scale fatigue as well as full-scale static test. You can see here the AAAU antenna which is flying in the Embraer aircraft. It went through the static test and the certification. That is what is important. And here what you see is our own aircraft as well as the DRDO, Rustum. We have this capability. So complete full-scale static test facility can be utilized by the companies, MSMEs. Apart from that, they also have material characterization. As you know, in any airframe design, the material data generation is a major and a key event. So we have to start with that. So we have state-of-the-art facilities which the private companies can definitely use. In addition to that, we also have NDT and NDE facilities. So what I am trying to say is, this cluster has all the design capabilities, testing capabilities till certification. So small company, it doesn't matter for us, big company, it doesn't matter for us. What is required is, you can work with us, you can grow actually along with us. Thank you very much.
We thank Raja sir for the nice talk and invite Ravi Shankar sir to please present the talk on the aircraft systems.
Check. Good morning, everybody. I am Dr. Ravi Shankar, heading the aircraft prototype manufacturing facility and the skill development facility at NIL. I am going to make a presentation on the capabilities and facilities and services under the civil aircraft design and certification cluster. Under this cluster, we have 4 divisions. The first one is the Radom Narasimha Civil Aircraft Center, which is headed by Mr. Vinit Kumar. The second is the Aircraft Mechanical System Division, which is headed by Mr. Lakshmi Narayana. The third is Aircraft Prototype Manufacturing Facility, which is headed by me. And the fourth division is the Quality Assurance and Airworthiness Division, which is headed by Mr. Jagdish. The Radom Narasimha Civil Aircraft Center has a gamut of strengths, starting from the aircraft design, where the facility has got expertise in the areas of configuration aerodynamics, internal model design, fabrication testing, airframe structural design, system design analysis, as well as kinematic design and analysis, as far as the aircraft design is concerned. And the aircraft assembly integration and flight testing facilities are available under this division, where they are extremely capable of carrying out work related to methods engineering and production engineering, structural assembly integration, system level and aircraft level testing, power plant testing, electric plumbing, flight testing and telemetry, along with flight data analysis. They have a very strong aircraft project management team. And these facilities, the Hansa VT HOH, Hansa NG, as well as RSPT-1N, which is the 14-seater, is presently operating under this division. There are major facilities in the areas of aircraft hangar as well as bonded stores. This division has got hands-on experience and having worked on various projects, including the Saras Mark 1, which is the 14-seater, the 2-seater Benicio trainer aircraft Hansa 3, as well as Hansa NG, which is now certified, the 5-seater general aviation aircraft CNM5, the 2-seater microlight aircraft, as well as the Saras Mark 2 project, which is presently undergoing. They are extremely well versed in design and certification in the as well as in FR23 as well as FR25 for Saras as well as CNM5, JAR-VLA, which is for the Hansa 3 as well as Hansa NG aircraft, and BCAR-S for microlight. They are having experience extensively in coordinating various certification agencies, namely CEMILAC, DGQA and DGCA. The aircraft mechanical system division, the capabilities and facilities and services available here are, this division essentially works on environmental control systems, life support system, cabin pressure CPEs, the cabin pressure control system, pneumatic de-icing system, and cabin fire protection system. They have extensively expertise in the areas of system specification and requirement for the above, system architecture development, analytical calculations at component as well as system level, design and sizing of the system, LRU level specifications, mathematical simulation, CFD simulation, 3D modeling, and CFD based simulation as well as system level testing. They have from the industry point of view, this particular division is looking for industrial support for supply of following ECS component primarily for the Saurus Mark II. The wish list is quite big. They have a lot of equipment from the ECS pack, which includes dual heat exchangers, air cycle machines, water extractor, also PRSOVs, SOVs, NRVs, and butterfly valves and all that. All these industry support requirements, we are going to post it on our website for the industry to see where exactly they could support us in developing these indigenization equipments for our Saurus Mark II aircraft. Along with the technical specifications will be put forth shortly. And coming to the LSS, that is life support systems components for the Saurus Mark II, there is another requirement list of about 8 components, particularly in the area of cylinders for oxygen storage, back valves, quick downing mask, mask storage box, passenger mask, pressure transducers, charging valves, as well as the altitude pressure switch. The industry could look at it and come forward in supporting the development of these LRUs. Further to the coming to the mechanical flight control system, the division is looking for support in the area of supply of aircraft bearings and cables, the design, development and supply of airworthy control yokes, design, development and supply of airworthy flap control systems, design, development and supply of airworthy dual ram electromechanical actuators, as well as special manufacturing processes required for FCS components. With regard to the aircraft hydraulic systems, particularly in the areas of landing gear retraction extension, nose wheel steering system, as well as braking system, we are looking for industry support in the design, development and supply of DC-driven hydraulic power pack, braking manifold for brake system, RTDs for measurement of brake temperature, as well as customized inline hydraulic fluid cooler for cooling of the aircraft hydraulic fluid. Coming to the aircraft prototype manufacturing facility, this is the other division under this cluster. This is essentially the manufacturing division for CSIR NAL, which undertakes the manufacturing of aerospace metallic components, sheet metal components, as well as tooling components for various aircraft programs of the lab, as well as other national and strategic projects that is undertaken by the lab. This division also has a NABL accredited metrology lab, which carries out all the inspection and certification of all the components, as well as assembly jigs and recertification of toolings. The division also carries out work related to point cloud generation and reverse engineering activities. It also has the responsibility of carrying out the aircraft tool design and jig fabrication and certification for various aircraft programs. Manufacturing assembly of internal models, another major activity that the division undertakes. This division has got facilities particularly related to CNC manufacturing, starting from a variety of 3-axis to 5-axis machining centers, starting with X-traverse or stroke of 700 to 2000 millimeter, and Y-axis strokes starting from 700 to 2500 millimeter, and Z-axis from 400 to 800 millimeters, which are essentially utilized for the manufacturing of various aircraft components, which are shown there. And these facilities can also be utilized by industry because it's being both 3-axis and 5-axis can be utilized by industry also to manufacture their requirements of components. We have both Siemens as well as Fanuc series of controllers to carry out these machining activities. In addition to the CNC machining center, the division also has a series of conventional machining centers as well as high precision shop line machines and jig boring machines to carry out manufacturing of various flight control equipments and other critical and precision components for various projects in the lab. One of the strengths of this division is manufacturing of internal models and assembly. You can see a gamut of various internal models which are manufactured and assembled and certified by the division. We can see the 1:20 scale Saurus Mark II, the LCA Mark I, the 1:7.65 scale LCA, the GSLV launch vehicle module 3, and various versions of LCA Navy and LCA Mark II and RLV, which have been modeled, fabricated and assembled at the division. Sheet metal forming and heat treatment is another major facility that is available in the division, and we have a hydraulic rubber pad press of 1000 tons with a bolster area of 1700 by 1300 mm, wherein medium to small to medium components can be easily manufactured using this rubber press. And we also have an equivalent drop-down solutionizing furnace to carry out all the heat treatment operations with a work basket size of 1450 millimeters to 2 meters high of components can be used, particularly large scale stringers and all that can be heat treated and formed in these facilities. Aircraft tool design, fabrication and certification is another important major activity that is undertaken by this division. As of now, there is an opportunity for the industry to participate in the design, manufacturing, inspection and setting and assembly and certification of wing, flap, aileron, assembly jigs, ICY gauges and associated tools for Saurus Mk2. In fact, the RFQ is online, and we recommend the industries to have a look at the RFQ and see and look for their response. Similarly, the horizontal stabilizer, elevator, the Emperor's thing, along with fin rudder, assembly jig, ICY gauges, this RFQ is also hosted online, and we would recommend the industry to have a look at these requirements. The other requirement that is going to come up is the assembly jig for the front fuselage, center fuselage, rear fuselage, and along with the complete jig and door assemblies, along with the associated ICY gauges and tools for the Saurus Mark II. This also will be hosted shortly. Coming to the metrology and calibration as well as the inspection facilities available at the division. As I said, this is an NABL accredited lab. It has got a wide variety of coordinate measuring machines, starting from 2.5 meter to 1.5 meter. That is the first one is an Icon Metris, and we also have a 1.8 meter by 1 meter CMM at Belur, and another 1.5 by 800 millimeter at Kodihalli campus, as well as for the small components we use the Upperlink CMM. And these inspection facilities can be used, have potential usage for inspection of aircraft components as well as sub-assemblies, ICY gauges and toolings. We also have a very strong large volume metrology activities which we take up for carrying out inspection and certification of large ICY gauges, aircraft assembly jigs and transfer gauges, and also we inspect and carry out reverse engineering and point cloud generation for various aircraft related components as well as base vehicle assemblies. Also, which we can see, we have totally 3 laser trackers with us, equipped with T-Scan and T-Pro, which help us in carrying out the inspection as well as setting as well as reverse engineering activities of various assembly jigs, which we see here. This is Saurus wing assembly jig, and we also did this certification and inspection of various activities pertaining to ISRO work, and as well as the Saurus fuselage assembly jigs were set, inspected and certified using these facilities. We have an electroplating and a painting facility job to carry out all the post-process production activities of various manufactured parts, and we also have a very good painting facility which is of 5 meter cube, which can cater to large scale assemblies also, which could be of use to industry. Coming to the third division, which is the Quality, Airworthiness and Assurance division at QAD. This division has got 5 verticals: the airworthiness, design assurance, fuel system, quality control, quality assurance and AS9100 activities. Coming to the airworthiness activities, this division prepares all the policy document pertaining to design of organization, design organization manual, design organization interface documents, and they also carry out the obtaining of certification for DOAs for both military as well as civil certifications, and they also have the responsibility of demonstrating compliance for airworthiness standards. The design assurance system, they also have to have the responsibility of preparing audit checklists and audit reports, and conducting audit assurance audits, and also evaluation of design subcontractors come under this division. The quality control activity here, they have to have the responsibility of preparing the product plans and PQPs, product quality plans, and also the QAPs. and they also are the team which will have to approve the approve the manufacturing of various subcontractors, and the quality assurance team under this division, they carry out all the audit checklists, and they are the ones who are going to finally evaluate the various subcontractors which are responsible for manufacturing of various for various projects, either HANSA or SARAS and all. The AS 91100 is another major activity which is undertaken by this division, and they generate the ABEX quality manuals or the AQMs and the divisional quality manuals and PQPs, and implementation of QMS, carrying out the risk management and conducting audits comes under the responsibility of this division. Coming to the Aerospace Skill Development Center, this is one of the mission mode projects which CSIR NAL has embarked as part of the Skill India mission under the CSIR Integrated Skill Initiative program. We are affiliated to Aerospace and Aviation Sector Skill Council, and we have obtained approvals to carry out 4 job roles, namely Aerospace CNC Machinist, Aerospace CNC Programmer, Aerospace Design Assistant Mechanical, as well as Design Engineer Aerospace Propulsion System under the Sector Skill Council of Aerospace and Aviation. We have a state-of-the-art CAD/CAM CAE facility here with 3D Experience 2023 version, CATIA V5, ANSYS, as well as Vericut 9.4 and Simco Edit, which are used to train the students under these branches of engineering. And we also have a very well equipped manufacturing lab. So these are the various training programs that are conducted at the division. We have carried out many trainings in the areas of CNC programming, trigonometry and calculus, MATLAB for engineers, aerospace design assistant, aerospace CNC machinist. One of the popular training programs in the area of geometrical dimensional tolerancing and all. And we also have responsibility to carry out training for under the National Apprenticeship Training Program, under the National Apprentice Promotion Scheme, that is the NAPS, under the Ministry of Skill Development. Here we have totally 6 trades under which we select the ITI course students in the area of electrician, fitter, machinist, mechanic motor vehicles, turner and welder, and we also train them for a period of 1 full year. And they also get trained in various other NSPF skills that I have already mentioned, and they are industry ready by the time they leave the lab. This is one of the very important programs that is conducted under the ASDC. And they are also paid a stipend as per Government of India rules under the RDA rules during the period of 1 year. Thank you very much.
We thank you, sir, for a very enlightening talk. With this, we would like to thank all the 5 cluster chairs. I'm sorry, there's a question. Yeah, please go ahead.
Thank you. This is a general question to all the clusters, which is quite inspiring to me. Do we have any policy where to start and how to end kind of a standard operating procedure to access the lab at what cost? Also for the training as well. So standard operating procedure. Anyone on the list, please enlighten us, please.
Just brief. If you want to access any of that which we talked about, the single point of contact is the business development group. I think he is here. Yeah, I think you should talk here. Yeah, it is a very best friend of mine too, Sridhar sir.
The question we have various questions. CSR guidelines to cast it. It's very lot of years already benefited. So participated to different program, we have different engagement. We discuss during engagement. Each program has its own SOPs. So in general, you can approach for testing service we have started.
So it's available to us.
Yes, we will get it.
Thank you, sir. Thank you very much.
So we thank all the 5 speakers. They have been very kind enough to accept our invitation and make some time from the busy schedule and enlighten us. And it's very important for all of us, especially looking into the composition of the audience today, wherein while our own colleagues have benefited from all the, the information that you have given us, we have the corporate giants like Adani, Tata Elxsi, who are also listening to the talk. And also the future of our nation. I see some of my students sitting here, so it's really the right forum where these talks have come aptly. Before we go to the, to enjoy the tea and get refreshed and come back after about 10 minutes time, the next session will be on shaping India's aircraft development ecosystem. And just to set the pace for the next talk, we will, our director has asked us to just bring to your notice, especially the corporates as well as our HAL family who have also joined us. We have hosted this request for proposal on the collaboration in research and development front, manufacturing front, commercialization of a 150 kg category loitering munition platform. This attempt is toward making Bharat Atmanirbhar in a much more strong way in defense. So this has been published in our Deccan Herald, as well as it is also available at our NAL's portal, http www.nal.res.in/en/tender. So we would request all the corporates to please have a look at it and let us join hands to in this noble cause. With this, we request all of you to please enjoy the tea which is served outside, and please assemble back after 10 minutes. Thank you. Very warm welcome to all of you. Let us initiate the second session today. This is on shaping India's aircraft development ecosystem. We have 4 eminent speakers. Lieutenant Commander Madhav Kandadai, who will, from Adani Defence and Aerospace. Then we have Dilip Balaji from VVD and Gurugram. Then our own Manoj Singh sir from HAL. And last but not least, Jairaj sir from Tata Elxsi. So,
morning, ladies and gentlemen. I am Lieutenant Madhav. I am head of the plant operations at Hyderabad facility. So here I'll take you through a mix of our experience, how we see the aircraft development ecosystem in India, and then certain steps what Adani has taken towards building the infrastructure and the system in India. So this is a very generic slide in terms of how we have divided the whole aviation sector into the civil aircrafts, the commercial, the different sectors. This is just to give you a picture about various, though the aircraft looks to be the same, but the technologies change obviously for various reasons. So going on, the challenges and the sectors where we are into, the R&D, the engineering, the manufacturing and the MRO. These are the broad structures where we work towards well. Coming to the R&D ecosystem, with respect to the civil airspace, civilian aviation, the rotary aircrafts and so, today we have found that there are lots of gaps with respect to the availability of skilled manpower who can do design of a system. Unlike research laboratories like NAL or HAL, in the civilian market, the number of companies who are working into core aerospace or aerodynamics or structural designs, there are hardly any people. Okay, except for one or two corporates who are there into the system. That poses a big challenge for us to understand how do we break into the market? Can we find the right people to do the job? That's the kind of challenge what we are looking at. And associated with that is that the latest technological hardwares and softwares which are required for the design and development of aeronautical systems, especially the civil aircrafts or the military aircrafts. So that poses another challenge to us. Coming to the engineering, this is the biggest challenge what I have seen in the last 15 years in the industry, is that there are enough number of people. Today we are working with Airbus, we are working with Boeing, we are working with Elbit or the Americans or the Russians. Okay, we get the design. The biggest chunk is the engineering of that design. Do we know process engineering? Are we able to do the process engineering of the design what it is coming into? This is the biggest gap what we are finding from the industry perspective. Okay, there are very good engineers, but like today what was presented from the NIL's perspective, that can we train them to become process engineers, either mechanical or electronics or electrical systems. This is a big challenge what we are facing. Okay, there are companies, there are small MSMEs, there are many companies who are getting into the field. They are trying to do the design development, but they are all working in silos. There is no synchronization with respect to the quality agencies or the OEM's requirements. So bridging that gap is quite a big of challenge. We are trying to get in as many people. We are trying to even send them abroad for training if it is required. So these things are few steps which we have taken in our company. Another bigger requirement is the manufacturing. So once the engineering is done, the manufacturing requires the right amount of infrastructure, develop a huge supply chain, and then again train the people for the manufacturing processes. Okay, so this is another thing where we have seen that there are corporates who are into this area for a very long time, but it's been more at a component level manufacturing. Someone gets a product design, all the specifications are mentioned, even the process of manufacturing is mentioned. Now when it comes to the manufacturing, there are very few people who have got the right machines to do the job, right test laboratories who can support them and so on. And again, here is again the skilled manpower. We have got very good technicians in India, right from ITIs and diplomas. We have been engaging them at every level, but there is no platform where they are getting trained in the right perspective. Like with the NIL's perspective today, I think we can take their support in training them in the right way so that the moment they are out of the college, we can engage them directly into the manufacturing sector. Going to the next major requirement is the MRO infrastructure. So once the aircraft or the system is designed, how do you service them? Today, if you look at in our country, with respect to engine, there is no proper MRO center in the country. The aircraft, a few components can be manufactured, fitted back, and there are trained personnel who can do the job. But again, bridging that gap is a big challenge with respect to the service. So this is just to give you a picture about the whole basics of scenario, what is happening in the ground. Okay, you can see that you might be wondering that there are so many companies in India, but they are not able to build a complete aircraft or system in India on our own. Why? Because at every point in this setup, there is a challenge. We don't have the right people. It's just not the question of money. Money is, yes, a critical factor. But the right amount of trained people, the right software, the right infrastructure is not available across the country where we can really be self-reliant and make our own aircrafts. Okay, especially the civil aircraft is much more challenging than the defense aircraft. The military has got its own types of requirements. At least we have HAL who can take on maximum of their responsibilities. But with respect to R&D centers, research organizations like NAL, the bridging of the gap, there is a lot of efforts has to be taken from our side as well as the government side to bridge the gap between the two. Coming on to this is something which I just spoke over the previous slide, is the lack of R&D centers for design and development. We just discussed on to that. Dependency on governments and subsidies and incentives. Because the government will also give us subsidies and incentives only in certain areas. It cannot be like everywhere we are getting an incentive or subsidy onto that. Then the quality manufacturing ability, the expert skills, the supply chain availability. This is another big thing which we are, there are lots of people who are there. We've got hundreds and thousands of MSMEs in India, okay, who are doing a very good quality job, but they are not systematic in their approach. They have a gap in their, we cannot blame them. It's because the size of the company matters for them. It could be a small 1 crore company or it could be a 100 crore company. But they don't have the wherewithal to support the supply chain, capacity enhancements and so forth. Apologies, there is an overlap here. Yeah, another biggest challenge is, with my experience, I could tell you that I was handling new product development for an Airbus project, for an IAI project, for a Boeing project, now working with the Elbit systems. Okay, there is not a single aerospace grade raw material available in India. Qualified raw material, certified by global standards. Okay, there are a few Indian companies who are trying to build the raw material. Agencies like NAL have supported them a lot, but if they are not approved to global standards, the respective OEMs will not allow to utilize that on any aircraft. As simple as aluminium, steel, carbon or glass, everything matters a lot. Because we don't have manufacturing companies who make raw materials to global aerospace standards. It's again a chicken and egg scenario where even if he is ready to make, the justification would be where is the volume of requirement, where is the test laboratories in India which can certify a material to the aerospace standards. Okay, that bridging of the gap is very much required from either side's efforts, from the government side as well as from the industry's side. We have tried to build that bridge. We are trying to get Indian materials certified for foreign products. If it is successful, down the line we should be able to do that. But I would request senior scientists from NAL that if the private industries who are trying to make this aluminium or steel or carbon or glass, if they can be certified for the global aerospace standards, because we can tell the OEMs that I have a company in India which can do this job, which can give us the right material. This will help us reduce the imports. This will help us set up our own independent industry within the country, and which will also reduce the cost of that particular aircraft in whatever way it is. Because the supply chain is such a big challenge that after the COVID crisis and the two wars which are going on in the Middle East and Europe, the cost of raw materials have gone up by over 35 to 45%. Okay, it's a huge logistics cost, as well as manufacturing cost, as well as the bigger challenge now some of the people might be aware of is called minimum order quantity. These are all small things with respect to the scientific community, but when it comes to the manufacturing industries, the minimum order quantity makes a bigger challenge for them to buy. I may have to buy a material which I may not use it ever, or I might use it after 2 years or 3 years in my production. So these things, to bridge the gap, if there is an Indian company, we can have a clear picture about how do we want to go about it, a material tested to the global standards, we can start working towards that Indian organizations. Next is, fuel dependency is something we don't have an control over that. The aviation fuel is very expensive. It has to be imported, processed and used. But again, cost of fuel is something we are not able to have control over that. The engine and MRO in-house manufacturing capabilities, we discussed that. And there is another thing, clarity in the government approval processes and regulations. There are lots of organizations like DGCA, DGAQA, CENILAC, okay. There is no way, there is no methodology which is defined that this is the sequence of work you need to do with these three organizations, the kind of documentation required, how do we work with them. The industry doesn't have a handbook kind of a thing to say, these are the step 1 to step 10 to do this job. So if such thing can be created or addressed, it will help the organizations to approach and get the certifications in the right way. Going on to our company's this thing, just to give you a small picture. So we had a tie-up with a company called Elbit Systems of Israel. We made a joint venture, and we made and delivered an aircraft called the Drishti, which is a Hermes 900 Starliner version of the aircraft. Okay, this aircraft was completely made in India. The aerostructure was made in India. Almost 65% plus of the avionic systems, electronic systems were component level manufactured in India. Some of the things we assembled it, tested them in India. Some of them we have got it sent back to the OEM, tested it and brought it, assembled, delivered to the Indian Navy, and it is a fully flying aircraft now. Okay. And so one of the things what we did was, as Adani, we did some mergers, we did some acquisitions. We have invested in a few companies which we know that they have got the potential to carry the technology and the manufacturing capabilities ahead. So we have done that stretch. And as a strategic pillar, what we have done is like our motto, one of the mottos is that the existing MSME ecosystem will not be disturbed, it will be utilized to their full potential. This is when the previous slide what we mentioned about if the company needs an investment to grow, we are there, and if they have the technology to do the job. If they need support in terms of financial support, Adani will support them provided they prove the technological capability onto that. So the ecosystem is not disturbed, we are helping the ecosystem grow with us. Adani Defence is as young as the manufacturing started in 2019. Okay, the company was set up around 2016. From 2019 till now, in the last 5-6 years, we have developed over 75 plus new and old suppliers who are exclusively doing the job for Adani Group. Okay. And so one of the second strategic pillars what we are doing is we are bringing in the technology, like the gaps which I was mentioning a few slides back. So how do you bring in technology? So we have tied up with few OEMs across the globe. We send our people for training because that infrastructure is not available in the country. We send our people for training with them for the design, for the engineering, for the manufacturing. They get trained and then they come back and do the job in India. With respect to one of the aircrafts what we are manufacturing, okay, within the span from the time the project was conceived, the first aircraft it was delivered. Within 8 months, the first aircraft was delivered from the Indian continent. Okay, because the way we work is like we work in parallel. We don't wait for things to happen one after the other. We send them abroad or wherever it is required for training, bring them back, set up the infrastructure and get onto the job. So that's the kind of confidence we have with respect to partners giving us the technology. And we have made ourselves as a decision that whatever technology we are bringing into the country, tomorrow that technology we should be the only ones in the world making that particular system. With respect to the UAVs what we started manufacturing, we are the global suppliers for that UAVs, and in the last 5 years we have delivered over 24 aircrafts to the country. We have exported them. So that's our third goal onto the way we work. And a quick brief on the Drishti case, particular ecosystem what we are seeing. Right from the day the Drishti development orders we got from the Indian military, Ministry of Defence. Okay, we set up before we start the work, we set up the quality standards of manufacturing, the assembly integration activities, whatever needs to be done. The people were sent abroad for training, again learn what is to be done. The process engineering was taught to them, and today we are in such a situation, if the customer wants us to do process engineering, our engineers are going towards that. We have been given independent drawings and asked that can you do the engineering of this and take it to the manufacturing. We have done that, we have proven to the world that this is what it is. So we have that capability. Electronic and electrical systems we are doing with our group companies within the country, in Bangalore and other places. Now again this challenge of engines still remains. Okay, so we are setting up an MRO facility in Nagpur, where the engine overhauling will be taking shape. It's a question of time. We are working towards that, and once it is ready, we'll be one of the niche players in the market to set up the engine MRO facilities. And the battery systems, yes, there is a huge challenge. Again, there are lots of players in India who are manufacturing batteries, but are they certified for aerospace standards? Not yet. So this is again something which we have a big challenge on, and we are working towards that. And okay, the PDI and the ATPs, we have done that, and the first aircraft has already been delivered to the Indian Navy. The second aircraft is getting delivered to the Indian Army. We have already sent the aircraft to Bathinda, and it's the process of acceptance. That's it. Thank you from my side. Any questions, please? Yes, please.
Little closer, especially for the aerospace sectors. Thing is, who has to do the job? See, MSP and all, they cannot go from the development, product development. They can only help in the process. But generation of design centers is very fundamental to the system. So, like if you take Western countries, Honeywell, Labour, and Safran, they are private sectors. So, but still, they are good design centers and development centers. Actually, that is the focus has to be done on that.
Yes, sir. That's precisely what I mentioned is that that huge gap we are trying to bridge it step by step. Because setting up a design, like buying the software is one of the simplest things to do the work. Okay, I am buying a relevant server or a computer to do the job. It's the smallest of the activity. But I need to find the right person to do the job. So this is a big challenge. Yes, we are trying to address that. That is why our initial stages, we are sending people abroad for getting them trained. Come back and start setting up the design centers. Today, not for aircraft, for the army gun-mounted systems and unmanned surface vehicles, we are setting up a design center in Delhi, where the people are getting trained on how to do the design. So that step we have started, but for the aviation wing, we are yet to commence that particular operation because so it looks like a very simple thing. It's the same SolidWorks or the CAD/CAM is used to do the job, but that's not the case. Someone has to understand the material engineering before he touches the design aspect also. So that skill development is what is a big challenge, what I was mentioning. Yes, we have started our journey towards that, and hopefully soon we'll have our own R&D center being set up for the aviation. Sir, please.
So thank you very much for bringing out the perspective from the private sector. Yours is a fairly new company, but belongs to a very large group. It is finding almost 100% echo when you say the regulatory process clarity. The monopolies on the engine and the other equipment which you would have probably faced. We are also continuously facing such issues. So I just want to discuss on the monopoly on the engine which you have mentioned as the from European and American suppliers. Since at NAL we are more on the design and development, and we are not for profit organization. So could not understand how this monopoly affects a large business group.
Sir, it is like this, sir. Today there are many companies, and I have also worked in a couple of them, who are just manufacturing components for engines. That's all. Okay, if you go one step beyond that and ask any corporate, do you have the know-how how to set up an engine, assemble an engine? No, sir. Do you have the the expertise to test an engine? What is all required? What are the 10 things required to work on that engine? No, sir. HAL's engine division is the only one who understands the full aero engine as a whole. We are not talking about the other car motors or something like that. So with respect to aero engines, so NAL being an R&D organization, you have your engine scientists who exactly know inside out of how to design that engine, how an engine comes out. But when it comes to the manufacturing, yes, there are hundreds of MSMEs who can do component level manufacturing. But even for that, one other challenge which I mentioned is you don't have the raw material in India. You are dependent on someone from abroad to give you the raw material. By the time the component is designed, proved, okay, now I have proved the component. Now, who will do the complete engine setup? Who will do the complete engine setup? There is apologies if I am wrong, that there is no private company in India who is doing an engine assembly, especially for an aero engine. Because the kind of understanding what is required, the kind of infrastructure what is required, currently it is not there in the system. Even engine MROs, civil aircrafts, we have been having civil aircrafts in India for almost a century now. Okay, there is not a single engine MRO facility in India. It goes all the way to Singapore or Europe and back to their OEMs. At the level of MRO also we are not able to do that. So that gap we are finding as a big challenge, because if you take an aircraft, just to give you something, almost 30% of the cost of the aircraft is the engine itself. Almost, depending upon the class of the aircraft and other things. So such a huge requirement, almost a century now, and we don't have the right capacity to even touch an MRO facility for the engine, forget at the manufacturing level. So this gap, now companies like Safran are coming forward to do the manufacturing out here. But it will take time for that to mature and develop into the Indian ecosystem of private companies also doing that. Like the French OEM himself is setting up the facility out here. Will he divulge the technology to the outsiders? It's a big challenge.
Themselves is not to divulge the technology.
Yeah, absolutely, sir. Absolutely, sir. That's precisely what we are telling about. See, today you go to the Army, Air Force or Navy, let us assume that, I can make an aircraft. A simple UAV, sir. A simple UAV. There is no engine in India. Okay. You take small quadcopters or rotary hexcopter or such things. You can get electrical motors. If you want a high quality electrical motor to support that, we have to import that. Forget the aero engines what we are talking about. Even for a small UAV, a small rotorcraft or a hexcopter, we don't have the right, the ecosystem in India joining together. That's a bigger challenge. What I would like to project is that there are many people working in silos. There is no single organization which can bridge that gap. If I cannot go to the market and say, okay, I apologize. There are 100 suppliers. Can you do this? Can you do this? I cannot do that. So that bridging of the gap is becoming a big challenge. You might have the know-how, you might have the technology, but how do we join hands to work together? That is the first step. Then comes the next step of buying. It's as simple as an electrically operated motor. Okay, we are not able to get it done in India for the aerospace standards. Again, the question of if it's for the military, the Civil Act comes into place. If it's non-military, DGCA has to approve that single motor also for us to function. Okay, so these challenges are existing, sir.
Thank you.
Thank you, sir.
Thanks for your presentation. You mentioned about the various requirements for aircraft ecosystem. I would like to know which one is Adani concentrating on. You said MRO, you said engineering, you said R&D, and the other one.
We are trying to do everything to build an aircraft.
No one has done that in India till now. So can you elaborate on which are you concentrating on?
Today, say for example, the senior scientists of NIL had already visited our facility. We started the UAV manufacturing, UAV composite manufacturing. That's the first step which we took towards. The last 5 years, we have developed, manufactured over 24 UAVs abroad. It has been exported, and 2 have been given to the Indian market. The third one is under process. So this is the first step what we did, about understanding the manufacturing. Okay. Parallelly, what I mentioned is that the people, like I don't know where to go train my people. So what I did, I sent my people abroad for training. So the engineering capability they have acquired. Today, if the designer, the OEM gives me a drawing and says that, can you do engineering right from tool design to the manufactured process engineering of that, my team has got the capability to do that job. So we are now, the next step we are focusing will be towards the design of the component itself. So that's a little early in the scenario. Yes, we will be inching towards that. Once we have that, because it all starts with manufacturing. So when it comes to the Adani facility, the few of the gentlemen like Ananda sir and all have come. Okay, they have seen that we have the basic infrastructure where we are doing the full aircraft fuselage itself, including all the subcomponents. So that is a step-by-step development, sir. Yes, we are going towards that design.
Thank you.
So during the course of your presentation, a lot of emphasis has been given to the training and getting the infrastructure in place in our India.
Yes.
What is the method or mode you are following to get the technology? But I feel the TOT is not that easy. Are we getting 100% TOT from the our OEMs, abroad OEMs?
Sir, just I'll split this into two parts. The first thing is about the training of manpower. My first batch of engineers and technicians were trained in Israel way back in 2018. After that, I have recruited nearly 70-80 people. All the 70 odd people have been trained by these engineers and technicians who have mastered that technology. So we have developed a training pattern for them with respect to that particular aircraft. There is nothing called a generic training. Okay. So it's specific to that aircraft, specific to that system or the subsystem, we are training the people. With respect to the transfer of technology, it's the same scenario. That initial days, the first set of documents were given by the OEMs that this is what you need to do. But subsequently, engineering that, re-engineering that, tool design, tool manufacturing, everything was done by our own designers and team in India. So that's how we are developing that capability on a gradual basis.
Thank you.
Any answer? Thank you.
So we thank Madhav sir for a very nice talk, and before we formally say thank you to him, we would like to give a token of appreciation. May we request Jatinder Singh sir, our advisor nominate, to please do the honor. Thank you, sir. Next, we invite Dilip Balaji from VVDN Gurugram to share his experience on shaping India's aircraft development ecosystem, his experiences.
Hi, good morning everyone. Thanks to NAL for giving such an opportunity to address everyone here. So I'm just going to touch a little bit on our existing aerospace manufacturing ecosystem and why more suppliers are required, and a little case study, a very short story on how VVDN technologies entered into this ecosystem, and then what solution what kind of approach is required to take this forward to build a better aerospace manufacturing ecosystem. So, looking at the history of Indian aerospace manufacturing ecosystem, it started in 1942 when HAL started building aircrafts, and then HAL ADA together developing light combat aircraft and twin engine based aircraft, advanced medium combat aircraft, then helicopter ecosystem, then NAL's indigenous civil aircraft ecosystem, and then the private players coming into picture like Tata collaborating with global OEMs, and now companies like Adani contributing to this ecosystem. So these are all at the top level. This journey itself is tremendous from 1942 till today, from where we started and where we are today itself is a tremendous journey for India. And these are all forming the top layer of this ecosystem. So from top to bottom, whatever is best possible, all these organizations, the government, private, everyone put together, they are trying to do it. Now I'm going to touch a little bit on the bottom-up layer, how new entrants can come into this ecosystem, how we came into this ecosystem, and how the top-down and bottom-up can merge at one point so that this moves towards a healthier direction going forward, right? So with this background, so a little bit introduction of VVDM Technologies is we are a more than 17-year-old company into electronics manufacturing. And with this background, how the government organization approached us. So there is a new technology coming up in aerospace, TSN, which is time-sensitive networking. It is an Ethernet switch where our government organization was doing a research for the past few years, and then they came to know that there are only two companies in the world who has this technology, one European-based company and one US-based company, and there is no readily available product for this particular technology. With this multiple years of research, they were still trying to fine-tune, and we should really appreciate our scientists to be more visionary, because when there is no final product available in the world and they want to implement this in LCMR2 in 2026, that thought itself is a little advanced and visionary thought. And for this particular technology in aerospace, there is a white paper launched in US where there are a set of experts who contributed to this. Take GE Aerospace, Lockheed Martin, Boeing, DDN, multiple experts from multiple companies together contributed that to only on the use case for multiple use cases for this TSN Ethernet switch in aerospace ecosystem. But in India, our TD technical director from ADA, as a single person, he has launched himself one white paper independently, a little more technical, deep diving into the concepts. So with all this visionary thinking and advancements, they are fine-tuning what is required, what are the requirements and how these requirements can be met. While they are doing this for a few years in collaboration with this foreign company, still they were not able to conclude on the final requirement and how it can be proceeded. So when they were trying to find some alternatives, they were trying to do that for several years. And they are purchasing this TSN Ethernet switch, which was developed for automotive 5 years back from NXP, from US. ADA is purchasing it to India, and for their study, they are opening that mechanical enclosure and they are looking into that PCB, where they are finding the logo of VVDM Technologies, and then they are googling about VVDM and they are getting surprised that it is an Indian company, and then they are reaching out to me, and then we are starting the discussion, and they are surprised to know that that particular product was designed in Pollachi, outskirts of Coimbatore, and manufactured in Manesar, Gurgaon. So there are a lot of hidden things like this which we should bring it out, so that we can try and build a better ecosystem. So not only stopping there, they understood that this technology is available in India with us, where 5 years back we have already implemented, but only thing is it is not airworthy, we have to convert it to airworthy. And then after that discussion, they wanted a 30 minutes meeting, but it got extended to almost a half-a-day workshop where there are multiple 3 switches in an aircraft, so it will interact with multiple systems. So they brought each division separate sessions so that they can modify their respective systems which can adapt to this new technology. And after a half-day workshop, they got a complete clarity. And then when they visited our facility, they were really impressed with what all we had, because we had 6 manufacturing facilities, Manesar, Gurgaon, and one in Pollachi. And not only the manufacturing facility, we do everything in-house, from design, development, testing, prototype, till mass manufacturing. We do everything in-house. We have done that for several different industries for electronics in the past. And when they found all these capability in-house in India, then they are going back and through word of mouth, they are spreading the capabilities. And there are 4 more requirements coming from different business units. And then we have developed more than 2,500 electronics products, and we have displayed almost around 50 products in our facility where they witnessed, and they were able to do the mapping on which is relevant to which particular product in aerospace and which division, and then they are coming back to us and circulating and encouraging us for a better contribution in that particular ecosystem. Right? And apart from this, they are also recommending our facilities with other government organizations, and through that multiple organizations are visiting us, and again they are doing a mapping, and then the feedback which we are receiving is there is a lot of existing suppliers at a small scale, and we are not an existing supplier, but we have all the facilities to contribute much better, right? With this insight and with this encouragement, VVDA Technologies is moving abroad for a lot of collaboration and a lot of things. So we have met more than 150 companies globally. Though in electronics, we are very confident that whatever is being purchased from a foreign country right now, we will be able to replace it with Indian content, from design till only for PCB fabrication at the moment we are outsourcing. But even that will be done in-house within 1 year, and we have acquired 100 acres of land in Pollachi where we are rapidly expanding to do everything in-house. Right? So with this background and with understanding a lot of other areas where currently we are dependent on foreign OEMs, when we represent this ecosystem, we have to contribute a little more. So there are some dependencies in foreign OEMs. So we started meeting multiple companies representing us in Dubai Air Shows, and we were one of the gold sponsors in Aerospace and Defense Supply Summit in Seattle, where it was co-organized by Boeing. So after going and exposing us in all these areas, we understand that the situation in India is not only for us. The entire world situation is like that. So when Boeing presented us the demand versus supply, the demand and supply are nowhere closer. So they have a huge demand, and with the current infrastructure, they are able to supply only very few percentage of that demand. So they are encouraging from startups till large companies, whatever is possible. I can give you one example. They are saying even if it is a HR consultancy who can support with the recruitment of an aerospace engineer, they are still onboarding them. So that is the level of demand that they have. Anyway, anything and everything related to it, they are accommodating. So the situation is not only for India, and across the globe it is like that. And we are in a better situation. Of course, there is a lot of gap and a lot of loopholes to be addressed, but we are in the right direction. So apart from this, there are a lot of other areas where only two European companies had this product for this high-speed camera for airborne separation video system. But similarly, as an R&D, we developed a few things, again 5 years back, but there was no one until last year when we started this division, and when I took over this initiative and started meeting these government organizations and private companies. no one knew about this capability. Even earlier when someone googled about TSN, though we did it 5 years back, no one would be able to come to know about what we had. So now trying to remove all those challenges, all those hurdles, and trying to expose what we can contribute to this aerospace ecosystem. And from there, now we have already been part of this ecosystem. We have started working on a few products for LCMR2, and there are a lot of things under pipeline, under discussion. Right now, with this example of how a new entrant can come into this ecosystem, of course, even in the ADSS in Seattle along with Boeing, we proposed a lot of things to the startups in the US. There were a lot of there was a forum where a lot of challenges like this was discussed, and while we are doing it for other industries already, we offer this for the startups in the US. Like if they are a design house, they can use collaborate us for manufacturing, and if they are manufacturers, they can collaborate with us for the design, so that at the end of the day they can own the product, and if they have some market insight and what product they want to develop, we'll be able to contribute there. And similarly, with whatever strength we have, unfortunately we were, fortunately or unfortunately, we were not qualified for that startup category because our revenues and the size of the company was bigger. The revenue is higher, and we have 12,000 plus employees. Right? In that area we were not into that bucket, but still we were able to help a few small companies over there. And coming back to Indian events, so after that successful B2B event, I recommended that particular event management team to come back to India and organize such things. And government of Telangana also supported them really well, and we had Aeromart Hyderabad recently, the same organizers. So that is going to be a recurring event in India. So earlier they didn't have anything in India. So with all these things, the collaboration is expanding. And when coming to this Indian ecosystem, these kind of events, say Aeromart Hyderabad, and last week there was IDAX organized by IAF, and these kind of forums is helping us, collaborate and meet each other. So now there are a lot of things we are learning from whatever NAIL has presented, and there are a lot of positive things that is happening. And now, how can we proceed further? So we knew what is the top to bottom that we have built already in our history prior, and now being a medium-sized company, how we have entered and how we are supporting very small companies, right? So here the only solution is, rather than competing with each other, we have to collaborate with each other. So that is the way forward based on my observation and my experience. I feel that is the way forward, and it is not something which we are not aware. We are much matured situation where for VVD and strength, what we can do with the small companies, we are trying to run ahead and pull them and move forward together. But large companies like Adani and Tata, all are very collaborative. Even with Adani, we met them in Aeromart Hyderabad, and they were all very receptive of what we can do. Of course, we are yet to take them to our facility and show how we can collaborate. But the way they received, even when your presentation, there were a lot of electronics that is being purchased from foreign countries, which we can do it in-house in India through us. So, and even in this IDAX in UAV, we do this RC2 drone communication complete hardware chipset, and we also do some counter US solutions also. We have done something to North America defense already, and even with Indian Coastal Guard, when they invited us to list down all the foreign products and how we can replace it with Indian companies, it was so surprising that the radars and few things which they purchase from foreign companies, those foreign companies are already our customers. So we are offering some service here, not the 100% of that product, maybe some portion of the product engineering. We are supplying there, and through there it is coming at a very higher cost to the Indian government. It could be Coastal Guard, Navy, Army, Air Force, whoever it is. Right? So that was so eye-opening for us, and that is when we felt we should be more faster in exposing us to multiple DPSUs and also private players like Tata, Adani, etc. and then we should all join hands together, collaborate, and then take this ecosystem to higher level. Of course, what we saw in Adani's presentation, they are already supporting the MSMEs and smaller companies. So that is what I said, we are all very mature. Based on each company's strength, we are supporting someone who is below us, smaller than us, and trying to bring them up to our level, and also looking up to larger players, and we are trying to grow. So we already have this healthy ecosystem, and this is the way forward, and we are in the right direction. So that's all I have. This is what I want to do. And one small thing is, at least in the electronics area, I put my hand up and I volunteer to say that if whatever foreign products are there, we are here to replace that, and I'm confident that we'll be able to independently do it by us. And of course, like I said, I have a very good backup ecosystem, meeting other companies across the globe, European, North American, Middle East companies, where if there is some collaboration required with this 20% Indian content is very easy, but we are targeting, we have already done several products with 70-80% Indian content. So our intention is to give maximum Indian content by replacing foreign product. And then if we do not have some technologies, not everything that we can do, but there are few areas where we can collaborate and take 50% Indian content. And apart from this, there are a lot of unattended areas where I would like to volunteer, and I would like to encourage. There are several other areas, right? In electronics we can contribute, but there are several other areas like structures, like engines, what we were discussed. So whoever has capability there, we all should come up and volunteer to do it independently without dependency on foreign OEMs.
Are you working in the area of electromechanical actuators?
We don't have past experience, but we have expressed our interest where we can do that. Maybe I would request if there is something you can visit our facility, understand our capability. We are interested to do it. If you are convinced that we'll be able to do it, we can definitely do it. Sure, sir. So when we started this in the month of November, with the same kind of approach, with the same kind of encouragement, my calendar was empty, and then now with all kind of enquiries and leads, it is getting full, and it is very good to see the kind of encouragement from the government side as well as private side for this initiative of replacing foreign product and indigenization. So thanks to everyone part of nook and corner of this ecosystem. We are doing a good job, and we will continue to do it, and we will achieve all the targets and goals of this building a better ecosystem. Thank you.
Thank you, sir, for your enlightening talk. So before we formally say thanks to you, we will like to honor you with a small token of appreciation. To do the honors, may I request Ravi Shankar sir to please honor the guest speaker. Thank you, sir, for the nice talk. Now we move to the third invited talk from our own Manoj Singh sir from HAL. We request you to please enlighten us on HAL's perspective.
Good afternoon, everybody. Actually, the question which has been asked, some time ago, and we have been wondering that is this our country ready, or is the ecosystem available to manufacture? In fact, sitting here, I should say a civil aircraft, and we have been telling yes, we have been we are ready. There is an ecosystem available in the country, and we'll be able to make or manufacture the aircraft. So today's topic is the aircraft development ecosystem. So I would be just touching upon the HAL perspective, or the perspective wherein how we have come out to develop the ecosystem in the country. So just to brief you that HAL being 79 years plus the old company, and we are located at 9 places in the country, and almost 10 R&D centers we have, and there are different complexes which works on different products, aircrafts, helicopters and accessories. So this is which is listed here. Now just to set the tone, because this aircraft which is available in the country acts as a catalyst to develop the ecosystem here in the country. So R&D which HAL has done, if you look at the fighter aircraft from Maruk, Ajit, and currently we have LCA as a platform in the country. Now trainer aircraft we have started with HTT-2, Kiran, HPT-32, HJT-36 and HTT-40, which is currently under manufacturing. Now there are utility aircraft which HAL has manufactured, Basant, Rishabh or Pushpak. And in helicopter, all of you know that we have LH, LCH and LUH platform, which is currently under manufacturing. Now, if you look at the portfolio which comes towards transport aircraft, HAL Kanpur division manufactures DO-228, which is now certified for civil applications, and currently it is being used for the civil application in Northeast zone. So, and then the other aircraft which HAL has manufactured, if you see Avro HS748, which is almost 40 to 50 seater aircraft, and from 1960s to 70s, HAL was able to manufacture under TOT. So HAL has been manufacturing some of the aircraft under TOT. Of course, if you look at the back history, where in 1970s, where we have manufactured Avro, which actually even Indian Airlines was using these aircraft for commuting. At that point of time, if you look at a lot of manufacturing, if you say, more than 80 to 90% was in-house. And there were supply chain which was like, importing these LRUs and other things which was being done during that point of time, and we used to assemble it, and then these aircraft were available for the users to use that. And then N32, these aircraft we do servicing and overhauling. Now future platform, which is shown here currently, in fact it aids to develop further ecosystem in the country. If you look at topmost right is a LCA Mark II program, and then we have AMCA. After that we have got IMRH product, which is HAL's its own design and development, which is under design and development. Then of course Saras Mark II, and then time to come we will have RTA in the country. Now the question comes is, are we ready to take up this, or are we not ready to take up this, or how much more is required? So the company like DPSUs or DRDOs or CSIR all together handhold the private or MSME to see that the technology in the country is available. Now when I say aircraft life cycle, it starts from design, then development. Now there was a time wherein the outsourcing from the HAL or anywhere was done mainly for manufacturing of the structural component or the system or the component. But today that is not the scenario. Today, even if you look at the design, where it is a concept design, where it is analysis, where it comes on the LRU development, there is an ecosystem available. There are companies who are in fact coming forward to take up these responsibilities. So I'm a little bit different from my previous speaker. We'll discuss on that. Then when it comes to development, now if you look at the prototype development of the aircraft, which is futuristic or which has already been done, so there we say that manufacturing of the component, which was taken up by all private sector companies, then a lot of testing, when we require long testing, wherein a lot of help were taken up from the private sector, where the supply of the test equipment is being supplied by the companies in the country, actually. And then applied testing and certification. So there is an area where if you say certification per se, wherein Semilac is involved or RDAQA, DGCA is involved, the know-how some years ago may be low, but today if you look at, everybody is aware of the system processes which is required for doing a Semilac certification, and there are organizations which are already certified by Semilac to take up this work on civil, or maybe time to come in a lot of DGCA's approval will be provided to the companies. You can take up the civil certified products. Then the other area which comes is production. Now production is one area where we have lot of support. In fact, today if you look at the aircraft like LCA, almost everything we depend upon the private sector, wherein supply comes and we act like an integrator over there. And then LRU, yes, a lot of LRUs where the bottlenecks are there. However, today with government initiative, a lot of indigenization is happening, and then time to come we will have a lot of LRU which is available. Test facilities, yes, test facilities are also being developed, and with the help of a lot of Indian companies which we are using currently for all LCA program or our own programs like helicopters or trainer programs which we have. And then the other life cycle of the aircraft will comes on the MRO. And MRO is one area where in military, of course, HAL is carrying out all the activity, and now we are involving a lot of private partners also to help us in carrying out these MRO activities. However, in civil, still there are a lot of gaps available, because as previous speakers were also talking about, that to take up the civil MRO, which is a huge chunk of business in the country. So the aircraft structure is one, then if you see engine, and then if you look at the component, everything goes outside the country. So we have got a lot of potential wherein the companies can come forward and look at the, in fact, if you look at component MRO, it almost bids more than 33% of the whole MRO capacity. That kind of a volume is there. Wherein if you look at only the aircraft which is available in the country, and more than 800 plus crores business is available in the country itself fully packed. The only thing is, the company who wants to take up these MRO activity, they need to get certified and they should have the know-how, and they should get a requisite training to carry out this MRO business in the country. Now, the biggest thing which has happened for development of the ecosystem is the government initiative in 2014, wherein launch of Make in India concept. So government has started encouraging to lot of Indian company who should come forward, who should invest. In fact, there were FDIs also were encouraged to do a lot of Make in India things. So encouragement to build in the country and then develop a lot of technology in the country has started in 2014. And that has given a good momentum wherein the ecosystem in the country has really developed. Now, second thing was again coming up to Atmanirbhar Bharat. So Atmanirbhar Bharat has again transformed, or again in fact I should say that we were all forced to look at that. Even if there is no technology available, you see that it is developed. So with the help of DRDOs, DPSU or CSIR, you look at these technologies are being developed. Of course, there are certain gestures wherein any technology can be developed. So right now, if you look at, if you go to the Srijan portal and see that what kind of a indigenization is being put. So more than 37,000 components which involve in a high technology items are also available in the portal. And to be surprised that in 3 to 4 years of time, there has been a private industry who has come and they have done more than 30% of those component indigenization in the country itself. And DPSU is able to fund more than 7,000 to 8,000 for these indigenization. So look at the volume which has come up, and then seeing that this ecosystem also grows in the country. So this is where these policies or these government initiatives have helped us to develop the ecosystem in the country, not only with respect to structural manufacturing or the component manufacturing. It is like a system, and there are like high technology items also is being encouraged and then being developed, and that is where we are today. Now, if you look at, again segregate the design and development phase. So now if you see the mechanical system design. The mechanical system design with respect, first you look at whether you can make a specification. So yes, maybe starting if I have a project, I start making a spec and give it to a private sector company. Today, a lot of companies are there who well understand your requirement, well understand the certification requirement. And over and above, if you look at the knowledge of, if I can say, the engineering, which starts with basic engineering and then come to the knowledge of the tool, wherein if you look at CATIA or Unity Graphics or any SolidWorks and all that, and they're all people are well trained. In fact, the organization like us, we have trained a lot of people in this tool, and then they are also aware of the technology, which can again, enhance while working with any other companies. And if you look at the technology-wise, like actuators, pumps, everything, there are private companies who are ready to take up these, system design. Coming to electrical and avionics, there are kind of a motor design. There is a ECB design, and those design today we are also looking at outside world to help us in designing those controllers, flight control computers or any other control computers. And we are able to get, even though these computers are kind of a safety critical item, so the companies are aware of what kind of a safety critical item means and what it involves in developing that, what involves in the hardware development, what involves in the software development, where you want to do a certification with DO178B. Those requirements are also well known, because the way we have been now offering these products to outside world, the know-how in the company is getting built outside to the private companies or to the MSME. The other area which is now in the beginning, if you look at during the design and development phase, is one area where a lot of private participations are there to build this ground handling and support facilities. Now if you look at, I have to build a hangar for any product, new product which is coming up, there are companies who builds, and when it is not just a hangar which is a facility. Hangar consists of your hydraulics system, consists of the electrical system, consists of an environmental control system which is allowing the aircraft for initial ground testing and then RFPs and other things. So there are companies who is helping you to build the infrastructure for your initial design and development phase. Now, if you look at in HL, we have got an accessories division. These accessories division is again divided into mechanical system, then there is a avionics system, there is a computers where it is being done. So these accessories divisions are also outsourcing a lot of work, lot of products to the outside world, to the private companies, and that is how, if we can look at this ecosystem, the country is getting developed. So there are opportunities. The aircraft which we build, the aircraft which we assemble today, or the aircraft which we develop, obviously there is a collaborative approach today, and there is an ecosystem available. That is a confidence we give it to the government that we are able to develop or we are able to manufacture the product in the country. Currently the challenge which I face is which I think of is, like if I have to do, or if the country has to do, take up a mass production of any aircraft, are we ready to take up that? So obviously yes, there is a problem, because there are a lot of bottlenecks over there. I think with respect to, if you look at, if I have to do a mass production, not maybe a prototype development, then I need to have a knowledge transfer, we need to have a skilled manpower, we need to have infrastructure, and we need to have a kind of a government support in terms of maybe funding to the companies who can help in building the supply chain to assist the mass production of any aircraft or any, whether it can be a military or a civil aircraft in the country. So to some extent we are ready to take up these challenges, but to a larger extent, still a lot of work to be done. And of course, with the current government initiative, of course, we will be able to pursue that. Now, just one small case study which I just wanted to bring out here, which gives an overall perspective of how we are involving a private sector to develop a technology. So now we have a product, we work on an unmanned aircraft. So we started working on converting the existing Kiran aircraft, which is a two-seater trainer aircraft, which is used as a basic trainer currently by Indian Air Force, to convert this as an unmanned aircraft. So this aircraft per se is called as an optionally piloted aircraft. That means always there is a pilot sitting there and it can be switched over to UAV or it can be switched over to the manned aircraft. So we started working on that. The challenge here is this particular aircraft is basically, if you look at the flight control system, it has got a manual flight control system. Now when I have to do when I have to switch over to unmanned aircraft, now I need to have switching mechanism. That means between, the control should be switched over from the manual to the automatic flight controls. Now there were challenges like we have, if you look at the controls over here, then you require a flight control computer, and then you require actuators which would respond to the command which is given by the flight control computer from the ground, station, and then the aircraft should fly like an unmanned aircraft. Now the challenge over here was to develop I think, electromechanical actuator, which should have a facility. I just give one example here. There are multiple things which is developed here. So that particular actuator should have a mechanism when pilot presses a button, say that you go to UAV mode, it should disengage the mechanical system which is available on the aircraft. So there has to be a clutch, declutch mechanism, and once it gets clutched to the UAV mode, it goes into it start interacting with the flight control computer. It acts like a UAV. So no technology was available in the country. There is a company which is in Germany, which has this type of technology, which provides the electromechanical actuator with clutch, declutch, and so at that point of time, when this government has launched this, that you need to have your own, first you explore that the Indian company only should be able to supply you these items. So now we had no other, like if you look at from the project point of view, I am just looking at only the aircraft to be converted to unmanned, whether the items are imported or item is built into the country. But this particular initiative has started us to looking at some of the Indian companies which has this capabilities. And we have got a company who had some experience in working on electromechanical actuation, and then they had a separate experience in doing some clutch, declutch, kind of a technology. And mind you, this particular actuator is a smart actuator which works on what you can say, on a command from the flight control computer, which is on a high response time. So it took some time, but that company today has come out with a product wherein, while developing this product, we have done a lot of hand holding, and if you look at, they are today aware of all the process, whether it involves how the RDA works, which they were not aware, and how Semilec works, what are the certification process, how a software certification can be done. So now this one example wherein the company who has come out with developing a product with the help of company like us, and tomorrow they'll be able to make any product. So that means one particular area wherein they got a capability of developing a critical software and their processes, developing a technology, and that is how the ecosystem in the country is being developed. So today we don't need to look at any country which is Germany or any French companies to supply to the nation any kind of this kind of a technology. Obviously those companies can further grow and then they can supply any kind of actuation to any UAV platform. So now coming back to how the ecosystem can help to develop the whole thing. Now if you look at different layers, so the private companies today, they are able to supply the component. Of course, raw material is a challenge and it is obviously to be handled, and it is being addressed at maybe the pace may not be the right way we expect, but of course that is happening. Then if you look at the tier 2 supplier, we have got a lot of suppliers who have initiated a lot of design work, and as well as they have do a lot of, in fact, You can say if we have a design, they are able to do the, develop and manufacture those regarding with respect to mechanical, electrical and other system. Jigs fixture design, there are company who does ground support equipment, ground handling. There are system which is available. Now when it comes to tier 1, when you look at, there are structural module, which I think there are company who are able to do that. Assemblies, sub-assemblies. The area which still we lack is a power plant. And the other area where we lack, I think what I feel is basically a sensors. The sensors which area is coming up, but they are in a very slow pace. So still we depend upon outside. So with all together, time to come, hopefully the ecosystem is going in a right way, and we should be able to integrate with the MSME, private sector, TPSUs, DRDOs and all together, and see that our dream to build everything in the country comes true. That's all I have. Thank you. Any question I am happy to answer.
Thought-provoking talk from you. We have not heard him talking on this front. We have mostly seen him talking about the technical fronts of FCS. So this was something totally different. So before we formally thank you, sir, we would like to honor you with a small appreciation. May I request Lakshmi Narayan sir to please do the honor. Thank you, sir, for the presenting talk. So we come to the last talk of this session, and we would like to invite Jairaj sir from Tata Elxsi to enlighten us on their experience in aircraft development ecosystem.
So good afternoon, everyone. Everybody hear me? Yes. Okay. So developing ecosystem in India, it's a very broad topic, and I'd like to before getting into the detail, I'd like to thank the colleagues from the industry who spoke before me, and I'd like to take a few of the quotes and references what they said. Not sure how many of you have joined on the day one of this event. Subramanian from SASPOS has spoken how the MSME in India is working with sweat and blood, not on the revenue side, the margin, right? So he kind of outspoken, and with the kind of concerns he had, and how he wanted to develop ecosystem in India. So probably I was thinking I can start from there. In terms of how the ecosystem can develop based out of India. I myself past a couple of decades worked in global OEMs for them to develop a product for aerospace, defense and space. And when I take a reference of NASA, almost same time as HAL or other aerospace entity in India has started. But if I look at it today, the number of tier 1s, the number of tier 2 ecosystem in US and in Europe, there's no way we can compare to it. So I just wanted to see what is that we have done different that we could do it. I think that's when I'd like to take a reference of Dilip, what he spoke just before me from BBDM. I think the collaboration makes more difference than competing with each other. When I say collaboration, people may think Airbus. I take a reference of Airbus and Boeing as an example. We all know they are the rivalry. Any parameter you take, they are the rival organization for all components, right? But I work for both of, whether it's a structure or it's for software, electronics, I work for them. I work for both of those entities. But you know what, the tier 1 is kind of a means for them to collaborate. Of course, Boeing and Airbus, they compete, but when it comes to tier 1, probably take an example of Honeywell. Honeywell becomes a bridge between, they supply to Boeing, they supply to Airbus, and they become a tool of collaboration. It may not be written anywhere saying that they are collaborating, but indirectly they act as a tool. And then for tier 1, and then gets into tier 2, and then gets into tier 3. So the collaboration is a means of, the ecosystem development, and I think that requires a transformation. It is not just one piece of element to be changed, but I think that requires a transformation. Even if you look at the German ecosystem, I think we should take a look at it, whether we repeat it or not, that's up to us. Like Mittelstand ecosystem in Germany, how it is operating, and you can compare it with our MSME ecosystem in India. We need to take a look at it, how they can be a global player, a global leader, but we are still struggling to, as SASMO's director said, Subramanian the other day, what is that we should do? I think, I don't have an answer, but I'd like to, each one of you to collaborate, join hands to cross that bridge. I think the opportunities are more. Probably, I'll, from there, I'll get into my next slide. Tata as an organization, I don't need an introduction. I think a couple of my colleagues from the industry have spoken enough on, referred enough on Tata. Tata is there in aviation for more than, almost, 100 years in India, be it in commercial, be it in defense, be it in components manufacturing. I think as a Tata, as a group, we are working towards it, and recently with the production for C295 for Airbus or for Apache helicopter for Boeing, I think the opportunities are slowly emerging, and Tata is playing a key role. Not just at Tata, I take a recent collaboration between Mahindra and Embraer. There is a C390, there is a defense transportation aircraft that's being worked by Mahindra to manufacture for Embraer. I think the opportunity is there for everybody, but we need to look at how each one of us can play, collaborate, and contribute to it. So Tata Elxsi is part of that conversation, and we are known for electronics and system integration. That's what it stands for, Tata Elxsi. And the embedded system, the mechanical engineering, or the industrial design for a product, or you take any AML. Of course, it's emerging. What it is in consumer electronics will be different for big capital product like an aircraft or defense. We need to look at it, how it can play a role here. There's multiple, there could be predictive maintenance, we talk about it, but we need to see how well we can leverage that, the emerging technology. Tata Elxsi is definitely pioneering in using those technologies, not only in the aerospace, but in automotive and in life science product as well. And the kind of customers we work, of course, you can see some of global OEMs there, and our experience is not shaped only by one vertical. It is not aerospace alone. Our experience is shaped by automotive. If I take the battery management system, the electronics miniaturization, These are something, it is coming up in aerospace, but this is something which is last 10, 15 years has been pioneered and made a significant progress in automotive, and Tata Elxsi is very well part of that journey, if I put it that way, right? I was asking myself a question in terms of what it takes for an ecosystem development in India for aircraft manufacturing, aircraft R&D. For me, there is a 5 critical piece of the pillar. One, we need to look at, of course, there is a traditional aircraft development. You have a Boeing 737, or Airbus 320 or Embraer 172. You have it, but you also need to look at what is future aerospace industry is heading into, whether it is unmanned aerial vehicle or urban air mobility. This is something we should look at it if required. The reason why I bring it up is this is not something Western nations have matured there. The technology is not matured there. It's still in a lot of early stage of innovation. And this is something we can play a role there, and whether it's an urban air mobility, the ground-based system, how the system will operate, the entire rack, what you see it in a bigger aircraft like A350, the same level of electronics is required even for a small 5-passenger aircraft for an urban air mobility. Then the question of how are you going to miniaturize the electronics, right? Those things will come in picture. So we need to equally put ourselves on the future aerospace as well. I think for India, I don't think we are behind on the urban air mobility or urban or unmanned aerial vehicle. And of course, we see a lot of indigenous aircraft parts manufacturing, component manufacturing, build to spec, build to product, all that are happening. I think that will generate a lot of revenue, a lot of interest. I'm sure without we putting any effort, that will happen. Because that's a need of the hour with the global supply chain management that is changing. The equation is changing, the political equation is changing. This particular BTS or product, all that will happen, and slowly a lot of business will get generated. And partnership and collaboration, and this is one place I'd like to emphasize on, and we need to identify right level of partnership and with whom we are partnered and what is the outcome that is expected. I think that is one other area. It could be with the industry, it could be with your partner, from the technology area, or it could be from academic side of it. And policy, I think enough spoken from many of my colleagues. And the talent management, and this is something which I like to touch upon on this area as well. When I take MEMS or a data science, and still a lot of the university, if I see the ecosystem, the microelectronics, the VLSI side of it, the academic is still, it's still budding, if you ask me that way. It is not well enough or sufficiently supporting the industry pace in which we wanted. I think this is one place we wanted to ensure the talent management should start all the way from academy, and then of course the industry is ready to take them up. I think these are the 5 pillars I would say it is required if it is we have to take it up in aircraft ecosystem development. The way I want to go further is I take 2 cases which helped us to talk as part of the ecosystem development in Tata Elxsi, how we have done it. One on the microelectronics, that's where I'll go get into the next step. When I talk about microelectronics, I take this mobile. I'm sure many of you have it. You don't have to get upset in an aerospace and showing a consumer electronics. But think about it, the kind of electronics it has got, it is almost same as computing power as your computer, but it does not have any power as much with your laptop. And the thermal footprint is absolutely nothing, right? Maybe 5-10 years back it used to get heated up, even that never happens here. There is no vent for exhaust fan. I think this is going to define some of our transformation in aerospace, right? I used to see a big box, LRU, 20 years back, 1U, 2U, 3U for radar, for flight management system and things like that. With a miniature station, I think that has to go. And we need to look at how this consumer electronics, the technology which is used, can be adopted for aerospace or airworthy product. And this is one of such a journey where we took the FedEx for Indian Defence System. Of course, the photo looks a little broader, but actually if you say it, it's almost the size of this mobile, right? And how we did it, the FPGA. Right? We didn't go for the traditional microprocessor way. We took it FPGA, that reduced the power. Once the power consumption is reduced, we look at how we want to reduce the space, because mechanically it can be encompassed in a smaller space. And we worked with our ecosystem in Bangalore for electronics manufacturing and for the mechanical items for it. And this is a 16-layer electronics PCB, and it's very much as much as with your consumer electronics that you can think of. But you know what? This has gone through the 178B, and this has gone through the 254. All the stringent norms you can think of it, this has gone through with all that model-based development. Because it's a control system for an engine, it's a FedEx. So you have all that exercise has been gone through, and that is where I see. I wanted you to see the microelectronics is the one which they really put more focus on it, and if that requires more collaboration, we need to ensure that collaboration happens, whether it's in industry or it is with university, or even whether it doesn't matter whether we are competing with each other or not. As I told you, even Airbus and Boeing collaborate, of course using different tools and methods, but why not us from India? So that's my kind of a question. The next question, next case, which I'd like to showcase is on drone or unmanned aerial vehicle. You might be thinking, this is heavily commoditized product, and you pay some 10,000 rupees, you get a full-fledged drone for you. But what makes a difference for your for a defense or for urban air mobility, you have to put your family member part of this urban air mobility. So what does it mean is it has to show and demonstrate the reliability, all the stringent guidelines it has to follow. Otherwise, it will not go through that exercise. So the way I see it is, of course, it's still, as in the industry, we are still in early stage, but this is where I see a lot of collaboration is expected. This is one of design what we did, where we took some of the sensor fusions, digital twin, all that were applied, which are traditionally used in other verticals like automotive. We took a model-based system engineering, digital twin. We took a battery design and what is the endurance needed, what is the capacity needed, what is the thrust needed, and if you put all of it, weight is increasing, and it's kind of a cycle. Once the weight is increasing, the thrust needed is more, and your endurance is coming down. So that's where the digital twin helped us. And I know many of the companies are still struggling to see a stable flight, but this is something which we have used our latest or advanced technologies like digital twin and the other autonomous way of doing the flight. We could do it within some 3 to 6 months on the stabilization part of the flight itself. The other thing I want to talk about is on the sensor fusion. The sensor fusion, of course, previously HAL Director also spoke on what sensor-based technology is still maturing in India. I think that is one other place we need to take a look at it. From Tata Elxsi, we take sensors of high-definition camera, radar, or it could be lidar. But the software-wise, we develop a sensor fusion algorithm that integrates all the feed and makes a perception of it, and then based on that, we will make an autonomous flight for a drone. And as of now, this is flying. And we wanted to take this particular product for our integrating with the 5G application, how we can use it for border security force, how we can use it for recently Wayanad You must have seen a lot of rescue operation. Humans cannot reach certain place, and these kind of equipment, which are damn cheap, and it's all built by our own engineers in India, and which we can make it accessible to our security force or the force who can use this and ensure if we can save more people. And of course, if you take smart city related, there could be hundreds of other use cases that a drone can support it. But if you look at the underlying technology, it's a microelectronics miniaturization sensor fusion. So these are something which I wanted to emphasize. It's not just a big LRU making a big box, but making a miniaturization will help us to cross that from what it takes from consumer electronics to aerospace, right? And probably I think one more, looking at the sensor fusion capability what we had in the Tata Elxsi, one of our global OEM came to us and said, can you develop a product for us? It's not that they cannot make an LRU, but they came to us only for sensor fusion technology. Can you bring all your high definition camera, bring LiDAR, and make a sensor fusion and make a perception of it, and then bring up all weather, all ambience, you detect about what's situation awareness, and that can give a better visibility for pilot, and you can do anywhere, anytime across the globe, and this can be used in an helicopter for a defense or for a rescue operation, and this is something which we have taken it. I think for me, of course, there is a bigger conversation happening in terms of can you do C295, can you do complete the platform manufacturing out of India, like Mahindra on C390. I think that will happen. But if you look at the technology piece of it, what it is needed at this point of time, that also requires an equal attention and collaboration, if you ask me. I think that is where we from Tata Elxsi, part of the Tata Group, complementing the industry. So I'd like to stop here for a moment and like to take a few questions if anything. Yes.
You are also involved in the indigenous development of embedded processors. So you can start development of your own flight controller instead of using Pixar, because it is like a open source.
Right, I definitely, yes.
Yeah. So just my question was on that. Instead of using Pixar, which is open source, you can start with your own flight controller.
Yeah, that's in our roadmap, and making electronics for it and complete that indigenous solution, except for the sensors. Like when I talk about the drone side of it, we can make structure, we can make all the harness and all the nuts and bolts. But when it comes to the critical components like motor, the battery, is still the LiPo battery which is required for the drone. We still, we are not there yet. As industry, we are not there. We have to, rely on some of our, neighboring country. To be honest, here China as an example. There's nothing wrong here. That's a current situation. But this is something. If you have to be a self-reliant, we need to look at every other technology, how we can mature it. Of course, we need to do a collaboration, which I definitely agree. Indigenous is the way to do it. At the same time, we need to collaborate as well. Yes?
So the last slide was the proximity sensor. So what is the distance you can detect with a helicopter?
It's up to 300 meters.
300 meters. So it's based on LiDAR and sensor.
It has got the three sensors. One is a radar, and high definition camera. So the reason for it is used in an helicopter for a rescue operation. So definitely the terrain is not all that great. So you may have to get into any sort of terrain. So we need to understand what is the rotor, the rotor blade, or any proximity that is happening. It has to alert the pilot. when it is, and it could be all means it could be raining or it could be snowing or it could be, or you know, it could be a pitch dark night. So all ambience, all weather condition, these are required. You know, some of it, like lidar, might help up to 100 meter. Some cameras can push the boundary, lidar can little more there. So this particular one for 300 meters can give that perception.
Is it for Apache helicopters? Was it for the Apache helicopter?
This is for the Sikorsky.
So it can be
part of Lockheed.
So it can be retrofitted to Indian helicopters also? No?
Definitely yes. That's why I say, you know, the tier 1 is a means to collaborate for, you know, competing parties like Boeing and Airbus. So if you know how for a technology, we can, you know, develop for any other parties or any other entities. Okay. Thanks everyone. Thanks again for giving me this opportunity.
Before we proceed with delicious lunch, we have a 2 minutes small ceremony, and for that proceedings I would request Dr. Pilaret from PNPD to please take over the class.
Good afternoon. We all know that Tata is a well-known brand and CSR is premier aerospace research and development laboratory. So on this occasion of 1 week, 1 team event from our lab, I am happy to bring to you that today we are signing an agreement with Tata Elxsi, that is for the sharing of the information to make the collaboration successful. We already spoken about the collaboration in the urban air mobility. So today we are joining the hands with Tata Elxsi and pool the resources for collaboration in the field of urban air mobility, test infrastructure and the test expertise. On this occasion, I request a team from both the sides, team NAL and the team Tata Elxsi, our CEO from the Tata Elxsi, Mr. R. Jairat, to come to the dais and make an exchange of the assigned area. Here the teams will be collaborating with each other, not competing with each other. Thank you. Please join.
This makes a perfect sense and perfect
Yeah.
platform for us.
I request our advisor, Dr. Jatinder Singh, to give a token of our love and memento to our advisors.
So we now break for lunch and we'll try to assemble back by around half an hour, 45 minutes. Same. Yes. The lunch is arranged at our canteen first floor.